the Institute of Marine Engineers, IMEI. So all these associations instantly came forward to support this initiative, suggesting topics and speakers. And especially, I am very thankful to Captain Mahesh Yadav, who has been coordinating a lot of these speakers. Captain Bhasin and Anil Devli, CEO of INSA, also extended a lot of support in suggesting what we should be talking in this webinar. And finally, Mr. Indra Bose, when he came back from US, within short available time, he also connected with all the speakers. And then we, all of us collectively, we have put a lot of these topics which you see on the screen, what Indian ship owner should be doing when he is at the crossroads of a lot of options available, a lot of challenges that are in front of him, how the technology will change, what is the kind of policy support that we require from government, and then what is the quality of marine fuel that would be coming up. Are there any interim strategies before the net zero goals that we reach, any shortcut methods that we can adopt? So a host of issues are there. So I'm not getting into the details because you have a wonderful set of panelists and 2 sessions which are awaiting to share their insights on this webinar. I also thank Fuel Spec, which is a catalyst. It's a product which can be used as a fuel additive to improve the fuel emissions and increase fuel efficiency. So they have also came forward to support this initiative. I thank them. So with these few words, I will introduce the first session of the webinar. Then I hand it over to moderator, Mr. Anil Devli, who will conduct the session. So I'm glad to inform you that currently I have about 160 delegates logged into this session, eager to listen to all the panelists. Thank you. Then let me quickly so today we have these are the set of panels that we have with us. I am not getting into the reading of the profiles because they are experts in their own domain and they are well known to the industry. And these profiles are available on our website, so you can later get into the details. We have Mr. Indranath Bose, who is the advisor to the Great Eastern Shipping Company, 50 years of experience in the maritime industry. Then we have Mr. Vijay Arora, who is the Managing Director of Indian Register of Shipping, IR class. Then we have Captain Mahendra Bhasin, who is the Chairman of BASA, and also who is the Managing Director of MSC Crewing Services Private Limited. Then we have Jitendra Nimagadda, who is the CEO of Mudra Group. He heads the maritime related businesses of the group. Then we have Sachin Kulkarni, who is a mechanical engineer from II, Indian Institute of Materials Management. He is the head of marine business for South Asia from Vatsila. Then Mr. Mukesh Kumar, he is the fleet personal manager of Bernard Schulte Ship Management. Then finally, we have Mr. Anil Devli, who is a well-known face on the Indian maritime landscape, who is the CEO of INSA. So with these introductions, I hand over the session to Mr. Anil Devli with a one final note that we have 7 speakers in this session, and being the first of its kind, we also encouraged the panelists to have a slide presentations because there would be a lot of issues that you want to showcase here or make it clear to the audience. But in view of the time constraints, I advise the panelists to maintain so that we have effective utilization of the time available for the discussion as well. So anyway, that control will be with the moderator. So over to you, sir.
Thank you, Mr. Ram Prasad. I'm not going to stand between this galaxy of persons in the panel 1 and panel 2, but I would be failing in my duty if I did not thank Future Fuels for this effort. It is exceedingly important for us as not just as ship owners, but even as citizens, to ensure that we move towards reducing our carbon emissions. And we in the shipping industry have taken a lead to do what needs to be done. During the course of these discussions, we will try and pass as much information as possible to all of you, because as you can see, most of the persons here are technical experts. I would just like to reiterate some general guidelines for the guidance of all speakers. As Mr. Ramprasad said, you are free to put forward a presentation if you so desire. I would request that each one of you limit your initial remarks or your presentation to a maximum of about 5 minutes initially. After we finish the first round of remarks and presentations, we can then try and initiate some discussion and panel discussion, which will through which we will try and answer some issues that come to my mind or come to the mind of a participant here. And just a request to kindly stick to your allocated time. I will definitely interrupt if you are exceeding beyond your allocated time, and please don't mind my doing so. So without any more delay, let me invite the senior most person amongst our list, our Mr. Indranath Bose, who also happens to be the chairman of the INSA Technical Committee, to say his introductory remarks, and we will then take it from there. So over to you, Bose.
Thank you, Mr. Devi. First of all, I would like to commend Gateway Media for organizing this particular seminar and bringing an awareness among everybody, all the stakeholders of this important journey for decarbonization. Now, what I would say that, the United Nations, they have a body called IPCC. So they have said that the whole world economy must decarbonize net zero by 2050. So in line with that, IMO and ICAO, we are responsible for international shipping and international shipping and aviations. They are revising their strategy that how to reach net zero by 2050. Net zero means that it is inevitable that some fossil fuel will remain in 2050. Actually, IPCC report itself accepts there will be, but there will be negative emission. That means you suck out CO2 from the atmosphere, and that negative emission will continue. So in that direction, IMO is revising their strategy, and it is going to be, we have to move over our ships into zero carbon fuels or lower carbon fuels. And it's an immense challenge before the industry. And as a ship owners, it's huge amount of risk because you have invested on ships with the thinking 25 to 30 years of life. And now the policies are coming that decarbonization is required. So the fleets of about 30,000 of large merchant ships and 100,000 vessels around the world. So they have to reduce their carbon footprint, and each vessel has got a lifetime. So some of the existing vessels have to be retrofitted sometime in the futures, in 30s, 40s. So that brings a huge, huge challenge. And these zero carbon fuels do not exist today. And a lot of research is required. So I will just leave my introductory remark at this point. Thank you.
Thank you, Bose. I would now request Shri Vijay Arora to give his introductory remarks, please.
presentation can be shared?
Yes, yes, please do.
I had sent the presentation to the organizers. I think they
Yeah.
do have that. In case
Yes.
they can share, I'll be happy with that.
Yeah.
Otherwise, I'll just refer to the presentation.
If somebody from Gateway Media can put up the presentation, please.
Should I share myself otherwise?
I think so, sir.
I'll do that, sir. I'm not able to browse my.
I will just see.
I'm not able to browse anyway. Without wasting time, I'll refer to the presentation. Yeah, this is the one. Correct. Thank you. So, good morning to everyone. I thank the organizers of Maritime Gateway and Future Fuels, along with the supporting organizations, for giving us the opportunity to discuss or to share our thoughts on the issue of decarbonizing shipping and issues and challenges. I go to the next slide, please. So this anything which starts with a strategy, and if you look at IMO has been working on how the various emissions which have been there in the atmosphere have been controlled over a period of time. We talks about NOx emissions came, tier 1, tier 2 requirements came, then it came to sulfur desulfurization, and later on it came out with the this IMO strategy on decarbonization and saying that how we can further improve the GHG emissions. So this IMO strategy was adopted in April of 2018. The vision was to phase out GHG emissions from international shipping as soon as possible in this century. And to achieve this, we desired that the combination of factors was taken into account, that carbon intensity should improve by improving the EEDI. Then we should reduce the CO2 emissions by 40% by 2030 and 70% by 2050, and to reduce the GHG emissions by 2050, all compared to 2008 levels, basically. So the framework was put in place. Can you go to the next slide? So to achieve the vision, there were short-term, mid-term, and long-term measures adopted. Short-term measures were from 2018 to 23, 23 to 30 are mid-term, and 230 onwards will be long-term measures, basically. We are currently in the short-term measures. And when we look at those measures, basically, we can see that if you recall, in 2018, we came out with something, SEAM Part 2, which talked about how the fuel consumption should be collected. And 2019, we started collecting the fuel consumption. And then in 2020, we have talked about that, how the new ships, the EDI phase can be advanced. And that is how the new ships are helping us to see that the CO2 emissions can be reduced. At the same time, we are coming out in 2023, where EXI and SEAM Part 3 are coming out, where in EXI will be using the IMO fuel consumption data, which is available with us, and to see that the carbon intensity indicator will be used to see that how both existing ship and the new ship combined together are able to help us achieve the 40% reduction of CO2 emissions by 2030. So we go to the next slide. So this is talking about the various phases of reductions which were applicable for EDI, mostly from the new ships. Basically, the success started from 2013. The efforts are on since 2013, and the efforts are on the direction that how we can reduce the CO2 emissions by designing ships in a manner that the fuel consumption is reduced. And as stated in the IMO strategy in 2018, the phase 3 has now been advanced to see that there are certain ship types of larger tonnage will be requested to see that they start building ships in a manner that the CO2 emissions are reduced. And this advance from phase 3 to phase will take place from April of 2022, where such ships, maybe gas carriers, container ships will be advised to see that they have further reduction factors of 30% applicable, basically. Go to the next slide, sir. As just stated that the combination of new ships and existing ships will continue for some time while we are using fossil fuels, and new ships are being designed with the higher reduction factors. Even the existing ships need to see that they catch up with the new ships, basically. And for that matter, IMO came out with the regulation, which regulation states that ships of 400 GT and above, and certain ship types which are mentioned regulation 25, and if their threshold value is greater than certain dead weight, then they are subjected to this regulation, basically. And that is how the attained EXI will be calculated. The required EXI will be calculated, and we'll be comparing that attained EXI should be less than the required EXI to see that the ships are issued the technical file and they are issued with the International Energy Efficiency Certificate. This will be mandatory. This will be mandatory from initial from 1st January 2023, coming on any annual intermediate renewal survey falling due after this date. But the regulation will become effective from 1st November 2022. I would like to little reinforce on this issue that 1st November 2022. I think that date is basically a very important date. By this date, the ship owner should ensure that this technical file, if it is possible, can be placed on board to see that the technical file is placed on board. And if in case the PSC boards the vessel, you have a technical file available with you. And then IEC can be issued when the surveyor boards on board after the 1st January 2023 for whatever survey, first survey falling due. We can go to the next slide.
I just remind you, your 5 minutes are almost up, sir. But
okay, sir. I may take 3-4 more minutes, sir, if you don't mind. Otherwise, I'll be faster, no problem. I'll be a little faster. But so this is talking about attained and required EXI, which I talked about. Here I have just given information as to what all documents are required, what all parameters required for submission for calculation of attained and required EXI. They on the screen, specific fuel consumption is required, engine power is required, capacity and deadweight and reference speed is required, and conversion factor is required. For calculation of the attained EXI, required EXI has a formula which talks about that we need to have the reference line value and the reduction factors are available. Here, the important point is that the reduction factors for EXI are compared to the phase 2 of EDI. That means today's ships which are going to existing ships, they have to match with the EDI of those ships which are built with the phase 2 requirements, which is a very difficult task, but the owners have to do that, basically. Here, a little more difficult task is that if the ships are built before 2013 and if they don't have the sea trial report, then there are little issues, basically. But yes, those issues can be resolved where if in case either you can opt for the option that approximate value can be used, or you can go for the CFD analysis. Approximate value helps you, but it is not so encouraging for the ship owner because the attained EXI goes on the higher side by which the ship owner is affected. But if the CFD techniques can be used to really determine the B reference because which is not available, then the ship owner is at peace. At least he is not affected, sadly, basically. We go to the next slide. So these are few other situations which can help us to, if the attained EXI is not less than the required EXI, everybody is aware of engine power limitation, then we can always superimpose certain fixtures like bulbous bow, or we can put some boss cap fins, or we can adopt for air lubrication systems. So these are energy saving devices which are available, which can be used if in case attained EXI is coming to be greater than the required EXI, basically, or we can use combination of factors also. Here again, I like to say a few things basically, which is important, that let us be very clear that if in case we are able to meet EXI today, it is good, but you have to meet CII also for all the times till the time you are going to operate these ships. So it is always better to improve your attained EXI to larger extent so that the design itself takes care of your operational efficiency, because the ships are old, they cannot operate more efficiently than what they are operating today. You can control to some extent, but if in case you can bring such energy saving devices fitted on your ships, you will be able to run these ships for a larger period, because the CII will be then this design efficiency will give you a factor in the CII part. Basically, we can go to the next slide. So this is again for the use of the industries, the people who are going to sail on board, because EPL, when used, basically the EPL, if used, it is not that you cannot override it. You can override it in certain situations which are mentioned in the onboard manual. Basically, it could be adverse weather condition, it could be rescue operation or avoidance of pirates, and in those cases you need to record in the onboard manager manual, and then you have to inform the administrator, the RO, to see that you did use it, and at the next port you see that you bring back to the normal. And records which are required to maintain the OMM manual are listed over here, which you can always, when the onboard manual will be there, they'll be referred to this. So we can put the next slide. So this is the calculations what we have done for the vessel, which are where the data is available with us. We have calculated and seen that this example is only for tankers and bulk carriers we have taken, and you can see the red dots are above the blue dots. The blue dots are basically the required EXI for tankers and bulk carriers. The red dots are above, that means the attained EXI is not meeting. So most of the vessels today, as you see, almost 90% of the vessels which are at least with us, basically they have a problem that they will not be able to meet unless they adopt some measures, basically. And the range in which the measures are required to adopt it may range from 55 to 75%, which may lead to reduction of speed from 15 to 5%, basically. So we can go to the next slide. So this slide is an important slide. Here we are talking about the CII part and the new regulation again, which is coming from the operational energy efficiency measure. Here we see that in 2023, when this regulation comes into force, already you have to have the reduction of 5%, basically, which from the 2019 data fuel database, which is there, 5% reduction, which people should have taken into account, but not many people must have taken into account. So there is something to be done on the operational efficiency measure so that you meet this. Otherwise, it is quite possible the ratings which are given A, B, C, D, E. There is a once you calculate that, we have given example over here for a certain ship where the required CII part is, let us say, if it is 10 and the attained EXI comes to 9, she falls into B category. But then, as and when the period lapses, basically the same ship, because of no further improvement, may go to C, D, and E, and that becomes a discouraging factor for the ship owner, basically. This can be explained in the next slides. The next slide we have taken again from our database, which is available with us. We have taken the fuel consumption data of 2020, and we have tried to use the data. If in case nothing is done, what happens in 21, 22, and 23? We can see that the ships are moving from more towards D and E category. And you can see in 2023, the percentage falling into D and E category roughly comes around 54%, whereas when you see in 2020, they are roughly around 44%, basically. So what is happening if nothing is being done? These ships which are in A, B, and C start going to D and E, which the IMO discourages from the point that they don't want a ship to have a rating, continuous rating in D category for more than 2 times or in E category. And that becomes an issue which needs to be addressed by using the energy saving devices. We can go to the next slide, sir. So these are the factors which are available. Basically, we can use, improve, operate. There was a SEAM, if you look at that, SEAM part 1 was there basically, but we never used SEAM part 1. It was kept on board. Not many ship owners or managers used it, but these are the things which can be used. We can listed over here, and we can see that how the operational efficiency can be improved. Here I have talked about something on the biofuels and the alternate fuels. Again, alternate fuels part, I have not discussed in detail, but I'll say that the industry is working on this, but it requires a good approach by various range of industry people, governments, lending institutions, plant, engine manufacturers, yards. They need to come together because they need to look into what the advantages and disadvantages of the various fuels which can be used, because this is it is not very clear, though we know the properties, but definitely the infrastructure needs to develop, the storage capacities need to build up. So these all things will lead to the understanding as to which will be the fuel which will be useful to us. While we know that the fuel which is seen to be visible is LNG, we have been using this fuel for a good amount of time. Our use with this is we are familiar with this basically, but we see that LNG can be a fuel which can be used for the next 5 years if in case we want to see that how best our CO2 emissions or decarbonization can take place. So we can put the next slides. So this is talking about the SEAM part 3, what all data is required, what SEAM part 3 will contain. This will be again listed based upon when the submissions are made. It is for information only that SEAM part 3 is required. The owners have to see that the implementation plan is aware and they are aware of how they will set the improvement into their own system to see that the carbon intensity indicator is improved or retained basically either in A, B, C category, but let them not go down to D or E category. And if in case they go from D to E, the corrective action plans need to be prepared and approved by the administration or the RO basically. So when we go to the next slides. As far as IRS is concerned, sir, we have made fuels for these types of ships. Gas fuel vessels, LNG, LPG are available with us. We have made natural gas fuel for coastal vessels and inland vessels also. We have made guidelines on methanol fuel vessels and for fuel cell power vessel installations, high voltage use of guidelines of high voltage shore connection system for ships and for battery powered vessels. Why these guidelines are there? We have put into guidelines and not put into rules, but to see that as more and more experience will be gained, we'll be adding them to see that how best then we incorporate them in rules basically. We can go to the next slide, sir. So this talks about what we have done till now, again with the use of the industry. We are thankful to the industry to help us do something on this action. We have been able to run 2 cement carriers using the B20 biofuel, wherein we attained a reduction of CO2 by almost 7% basically, and there was no impact on NOx or SOx basically. That is also a good point. We are working with the yard and the engine manufacturer to have hydrogen power cell vessels ready by maybe by this year, and we should be able to have such a ship operating. And we have also operated one first vessel basically, which is on this Cochin KMRL, which is Cochin Metro Rail Limited, basically, where it is the hybrid propulsion has been used, and we have been successfully utilized the lithium-ion battery for operation of such a vessel. And we are working on the approval of these lithium-ion batteries once they are going to be manufactured in our country, basically. So the last slide talks about what IRIS can do for the industry. We have prepared a web-based electronic tool which can help us to do the EXI calculation. It is simple. You feed the data, it is available. And if the attained EXI less than the required EXI, the technical file is prepared and can be submitted straight away to IRIS for approval. And we can undertake these EXI assessments, issue you IEC certificate. We can help you what energy saving devices can be fitted by using our CFD analysis. We have also prepared the CII tool, which can be used again for measurement of CII ratings, basically. And at last, we can conduct various trainings and workshops like this to see that how best we can help the industry. We are geared up to see that how best in the initial phase of short-term measures, we can help the industry. And we are always open to any desire the industry may have and obtain from us, sir. Thank you, sir. Thank you, sir. Sorry for the delay, but
no problem. Because the whole idea is that we talk something initially and then leave space for discussion so that the those who have logged in are able to benefit from the expertise of all of you speakers. I will now request Captain Bhasin to please say his piece. Some of the feedback that is coming in from people is that our volume is very low. I would therefore request each one of you to try and make that little bit of effort to be a little louder so that those who are logged in are able to hear our voices. Thank you. Over to you, Captain Bhasin.
Good morning, sir. Can you see my screen?
Not yet, sir. Not yet.
Sure. Okay, just give me a sec. Sure.
It came on for a minute and has gone off, sir. Yes, we can now see your screen, sir.
Good morning, sir, to everyone. Thanks to Mr. Ram Prasad and Gateway Media for giving us this opportunity. The subject is so technical, and I was very glad when I was approached to give this presentation, because I always maintain we are people-centric. I'm in growing and training. And my presentation is going to take a different perspective for everyone, because there are so many learned people, panelists are here who have spoken for technical matters and going to speak further. So I'm going to show you something different. Future fuels. I put it as a digitalization and decarbonization, safety aspect. The biggest thing happening is we are definitely heading towards a digitally smart and a carbon neutral future. That is for sure. There is no going back. And the process is transformational, is not just transition, and the impact on the ship operation can be huge. So we always must keep in mind the crew and the ship, the seafarers. My presentation is going to be on something like this. I will also be skipping few things because Mr. Devli has said to be within the time. Operating geographically remotely in the vast ocean with a handful of people exposed to perils of sea. Shipping is actually aptly defined as a safety critical industry. So how robust is this transformation process? A proper risk management system in place, because that will ensure resilience. Is the safety being compromised? Now, this is the sum and substance that I will speak today. Now, what is digitalization doing? It is catalyzing a wider use of data, data-driven models. I repeat, data-driven models and remote services in shipping, leading to the improvements in efficiency and productivity. You will also notice I have put the heading instead of future fuels or decarbonization, I've said digitalization and decarbonization, because they go in hand in hand. Same time, the industry is also trying, something is wrong in my thing. Same time, the industry is also trying to find pathways towards carbonization. In many cases, it is the digitalization that is enabling innovation in decarbonization as well. Innovative technology is central, sure, but insufficient in isolation. Why did I say that? The success of these transformation depends on people who are the sharp end of business, the seafarers who perform and who deliver. You may ask, what are the safety concerns in digital transformation? This is a very, very simple and beautiful diagram. System is actually a set of humans. All of us are here. We are humans. We are involved. A lot of us are involved in R&D. We are humans. So humans, organizations, technical elements that together can achieve things. The people who produce technology, who facilitate, and the technology facilitates the people back. Technology influences organizations, and organization influences people. It's a circle. Anything you do, sir, in your life, any innovation, decarbonization, speed reduction, anything. So this diagram will always stay with every R&D people all over the world. We also must appreciate while digitalization can replace manual tasks with technology, it also creates more distance between a person and an operation. That's why I use the word isolation. But at the same time, interconnected software dependent on algorithms can be susceptible to interruptions and lack human-machine interface. So the industry, what they should do, the maritime industry uses many industrial platforms that have limited standardized interface. The responsibility for this integrated software is also spread across vendors and suppliers. In the last, they lag much behind the accelerating digital developments. The safety regulation needs to be on side by side, and that is where the human comes in. Solutions. What should be done? Verification method of future systems should be based on a systematic perspective on safety that consists of people, organization, and technology that all are related to each other and their environment. As a matter of fact, close collaboration throughout the entire life cycle will greatly facilitate system integration. System assessment should generate evidence for safety. Simulation, I have put it in the bold, can play a major role. Simulation can help to test and verify safety levels of the system without creating a risk to life. Another way to conduct this verification is by using digital twins that include dynamic update on conditions and operational parameters. Now I'm coming back to the subject. I was very glad Mr. Bose and Mr. Arora spoke most of the things. So I'm not going to dwell much on the other one or two slides. Only thing, keep in mind that by latest 40% by 2030 and 70% by 2050, that the IMO has set this ambitious target. To achieve this, shipping industry needs to unite in taking urgent action. I'm going to skip this slide already shown by Mr. Arora, sir. Sir, there is a growing pressure to reduce carbon emission. But the industry also started forming coalitions, launching pilot projects. But where are we going? Where have we achieved? Do we have enough data? This is the most beautiful slide. I think every person who is doing R&D should always have that. Because CO2 emission reduction potentials of individual measures. It talks about various things we can assist along with the fuel. Fuel is one of them, alternative energy source. You can see vessel size, hull shape, power propulsion systems, operations, voyage optimization, and all these do play a major role in CO2 emission. And digitalization, you all know, plays always a major role in this. While industry is exploring several alternative fuels, okay, there are 2 minutes more. Alternative fuels, including hydrogen, ammonia, but shipping leaders say they have commercial and technical limitations. Mr. Arora spoke about EEXI, very important date, sir, 1st November 22. Owners, administration, industry need to be ready for that. Something of the current thing. LNG. LNG is 20 or 25% less than the carbon intensive plant. I will read the highlighted area in yellow. It took many years for LNG to become viable. It is the only alternative we have today, and it will get us under 2030 IMO target. What happened after that? That's what we are all discussing. Other alternative fuels, hydrogen and ammonia, biofuels, methanol, ongoing research and development will tell us about future fuels of above. Well, I will not touch much on this because it was spoken briefly earlier. What are the future technology and the requirement, objective? Safety of the crew, safety of vessel environment, running of vessel efficiency, economically timely, complying with all regulatory requirements. These are the things we are going to have, all the things on the screen for the training of the people, especially structured value added courses, ample simulation exercises, knowledge sharing from experts, on the job training. You are all aware for LNG, there is a requirement for the people going on board must have 1 month sailing and 1 bunker operation. So these are good things, on the job training. In conclusion, sir, digital transformation calls for system integration and the new ways of managing risk associated with complex systems. Transformation to carbon neutral shipping requires stakeholders collaborate to increase transparency and create a culture of continuous learning. Most important, both these advancements should be complemented with efforts to keep people in loop, so that the innovative technology that is designed, maintained, and operated by optimally performing people in organizations that embrace holistic risk management is what will put the industry in the best position to transform itself through the digitalization and decarbonization. Thank you, sir.
Thank you, Basin Sab. I will now quickly invite Mr. Sachin Kulkarni of Wärtsilä to give his introductory remarks and presentation, if any. Mr. Kulkarni.
Stop here.
Yeah. I'll share my screen.
1 second.
Meanwhile, if from the audience there are any questions, I can see some of you have posted. Please also try and if the question is directed towards somebody specifically, please put in the name of the person to whom the question is addressed. We will try and answer them. Yeah.
Can you see my screen now?
Yes, we can. Please go ahead.
Yeah. So good morning, dignitaries and wonderful participants this morning. And thank you, Gateway Media, for giving this opportunity. A lot of wise and advisory words have already come. What I'll try to do is next 5 to 7 minutes, just touch base on the future fuel parts and the fuel flexibility part of it, and how Wärtsilä can support the ship owners and the shipping industry in large. Yeah, so we have seen that IMO targets for 2030, and then it's very clear that compliance can be achieved in the short term by optimizing the vessel operations and the basically introducing the slow speed, which we call as engine power limitation. However, when we look at the IMO 2050 greenhouse gas targets and beyond, then we need to consider the introduction and the transition to the green fuel. Now, the challenge here is that there are many different options, and at this point of time, no consensus on which future fuel will be commercially available. So commercial availability depends on various factors, that is geographical location, the national interest of the particular country, legislation, and the availability of the feedstock. Now, these uncertainties create a business risk regarding the fuel availability. So there are certain factors which ship owners must be considering while taking the decision forward. The increased capex and opex associated with this, the vessel design, structure, storage, and the handling, including the complex setting in managing the cryogenic condition of the fuels and the toxicity. Then we also have the timing issue. When should one make the investment and go for another fuel? We have limited amount of shipyards, and at any point of time, it will be not feasible to upgrade all these vessels or build a new vessels at the same time. So these are the factors one is to consider before taking the decision. So then what is the solution forward? We believe that investing in flexible fuel solution mitigate the business risk associated with the future fuel. The combustion engine is fuel agnostic. The business impact of future conversion can be reduced further by preparing the fuel tanks. So what we are talking about here is that combustion engine, basically it's important to understand that the engine doesn't really care whether we feed it LNG or ammonia. It's also important to remember when building a new ship, is the fuel supply system to be factored. This is perhaps the toughest thing to do to change during the retrofit project. And while building a new vessel, one needs to think about the storage part of it. These kind of tanks used installed today need to be suitable to the transition and to use the green fuel in the future. So in Wärtsilä, we shall continue to support and supply the complete system regardless of the fuel. We are ideally positioned at this point of time to provide the complete integration solution, the complete fuel propulsion package from the tanks, the fuel supply system, the engines and propulsion. So if ship owner has a diesel engine today, and what it can be done at this point of time before we have green fuels available. So when we look at the diesel engine, there is a potential of upgrade. We can look at improvement in efficiency via different upgrades as such. We can also look at the conversion of engine to DF or Lng engine and LNG, and it can derive or it can give certain amount of reduction potential, as we can see over there. Then if we have multi-fuel engine as such, then it's already an advantage position. Then we look at the improvement in efficiency via different upgrades again, and we also can look at reduced methane slip. So when we look at the milestone till 2030, there are various ways. If we look at EXI plus optimization of vessel operation plus LNG as a fuel, this could be the recommendation. And then moving forward, then 2040, and once the green fuels are available, we can look at the carbon neutral fuels. So the continuous development of technology in Wärtsilä, our future fuel roadmap is very clear. When we look at the biosynthetic methane, it contains 99% methane, and then it can readily be used in liquid form with equivalent equipment made for LNG. Then we have methanol. Its conversion package is available already for one of our engines, Series Z40, and pleased to share with you all that we already have then another engine, Wärtsilä 32, is already now compliant with methanol usage. We have the technology, and now we are looking at industrializing this technology on the different portfolio of Wärtsilä engines as per the market needs. When you look at the ammonia, again, there we have a technology which is capable of using ammonia. At this point of time, needed a combustion concept to maximize engine performance and the safety aspects which are currently investigated. Hydrogen, our gas engines are already able to blend hydrogen with the LNG up to 25%. And we are currently working on defining the technology for pure hydrogen and focusing on maximizing engine performance. So while this is happening, all research and development is in process. How the ship owners looks at the situation currently. So the transition fuel is something which is necessary to cope up, and for that we don't have green fuel available yet. So customer need to act, ship owner need to act now if they want to reduce this greenhouse gas emission of their vessel fleet. Conversion to LNG is one of the best option available because the multi-fuel engine opens up more options to reduce GHG emissions further in future by allowing a transition of biosynthetic methane or green ammonia or methanol when they are available. As a ship owner, what they do, what should they invest into at this point of time, and what are the operational consideration is to be done. So as typically summarized here, one is to look at into sustainability of the fuel, availability, its price. Then it's also important to see the required vessel endurance. When we look at the different fuels, due to the low volumetric density of the different fuels, the vessel endurance could be different. That needs to be considered. The tank size and the location is another important operational aspect to be considered. Blending versus pure. What are the output requirement? What are the efficiency requirements, emission, and then along with these green fuels, then if any exhaust gas abatement is to be done. What are the system to be changed when we're looking at introducing a new fuel? So from our side, the input is basically we can look at fuel gas supply system. That's very important part of the system. So there we need to look at the materials. We need to look at the very different pressures, insulation and toxicities associated. A small modification, we talk to the engine top part, fuel injection system, cylinder heads and piston tops, exhaust gas abatement like SCR, scrubbers and carbon capture depending on the particular fuel which has been looked at. And of course, importantly, safety systems, impact of marine classification on safety systems. So these are the few changes which would be associated when we are introducing a new fuel. So as a summary, what are the key takeaways from here? There is no single future fuel. There will be a whole variety in use. Investing in fuel flexibility will mitigate compliance and business risk. Wärtsilä will continue to supply a complete system regardless of fuel, and the multi-fuel engine offers a viable upgrade path to future fuels. With this, I would like to conclude my opening remarks. Thank you. I hope I could maintain the time, Mr. Devli.
Yes. Thank you. Thank you very much, Mr. Gupta, for having ensured that you are within time. I will now invite Shri Jitendra Nimagada, CEO of Maritime Mudra Group, to make his presentation or his introductory remarks or both.
Thank you, Anilji. A very good morning to all the fellow panelists and all the participants who are part of this inaugural webinar conducted by Future Fuels. I would like to appreciate and commend the entire Future Fuels team for bringing out this particular relevant and then most burning topic right now to the forefront of the discussion. So let me just share my screen. Uh, is my presentation visible?
Yes, it is. Please go ahead.
Yeah, thank you. Let me just quickly run through like what is the current status and what are we looking at from the emissions point of view. So just a quick numbers from the global maritime industry, it emits close to about 940, 950 million tons of CO2 per annum, which is almost equivalent to what entire Germany emits in a year. So it also accounts for about 2.5% of the entire global GHG emissions. So with the entire focus on the emissions and then its reductions across industries, across the globe for all the countries put together. So there is a lot of focus on the maritime industry to reduce its emissions, considering that it plays a significant part in the emissions that come into the environment. So the IMO has brought out a strategy on the reduction of this GHG emissions, keeping 2008 as a base year. So we are looking at a target of a 40% reduction of the CO2 or a one-third of reduction of the overall emissions by 2030. And by 2050, there is a target of reduction by 50% the as far as the overall GHG emissions and a 70% reduction in the CO2 intensity. Of course, having said that, there has been a mounting pressure that the decarbonization has to be 100% by 2050. So this is something where the industry has taken steps in terms of moving ahead with this particular revised target, or I would say the informal target. And we are also seeing a lot of initiatives which is being taken by the industry. So what are the kind of future fuels that are currently on the radar in terms of meeting this kind of decarbonization targets? So we are talking about LNG as an immediate intermediate fuel in terms of reducing the CO2 emissions. And there have been a lot of vessels which has already been flying commercially, bunkering happening. We are talking about other fuels like methanol, hydrogen, ammonia coming into the picture, into the frame. Biofuel is also the other future fuel options. So whether anything has been finalized, whether something has been taken up by the industry as a standard, well, it depends on several factors. So it depends on the kind of technology on board and offshore. What is the kind of energy density that each of this fuel delivers? The safety requirements of the vessel, of the onshore, as well as the crew. The scalability of this particular technology and the availability of this fuel across the globe, the ease of transportation from place to place, and of course, the financial viability. Of course, these are the major factors which will determine which of these fuels or a combination of fuels will be becoming as the options for the future fuels. However, the jury is still out. I mean, this is still some time, at least in my mind, at least it's about 5 to 10 years away before a fuel gets or a combination of fuel gets finalized and the industry moves towards its standardization. But what about now? My slide or my presentation talks about the current and now. So while we are discussing about the current, the future challenges and the kind of technologies or fuels which will be available, right now we are talking about at least one third of the entire vessels flying in the world today have a life of up to anywhere between 10 to 15 years. You can see this in this particular slide. Sorry, in this particular slide, the age of these vessels from its categories. So while we are discussing about the future fuels, what about now? I think that is an extremely important thing, saying that what is the transitionary option or a viable solution which is required for the existing vessels before a new age vessels or new age fuels becomes a gold standard for the industry. So that is where we present a product, a combustion catalyst called Fuel Spec by the Mudra Group. So what is Fuel Spec? So it is a patented fuel-borne combustion catalyst, and it's an organometallic compound which is orange in color. It's basically a liquid, which when combined with the fuels can reduce the emission reduction, can reduce the emissions of the particulate matter of CO, CO2, and NOx. So what does it contain? It contains basically the iron and magnesium at a scale of nanometers, less than 10 nanometers. And the medium, that is the lubricity agent, is a carboxylate ester. A few more points in terms of its pour point, flash point, density of the product. So what is its functionality, or what does it do to help in reducing this kind of emissions? So it basically improves the thermodynamic efficiency of the combustion of the hydrocarbons and through a catalytic process. So it's a patented and a proprietary technology based on electromagnetic emission spectra complementarity. So what does it do? It actually leads to a complete combustion of fuel. So normally in any kind of combustion engines, you'll always have certain amount of hydrocarbons coming out as unburnt hydrocarbons. So the combustion is not 100%. That is where also leads to excess amount of emissions, whether it is the soot or particulate matter, the UHCs, NOx, CO, etc. So because of this complete combustion by the fuel spec, there is a reduction in NOx, what we have observed from the empirical results as well as the field trials, by up to 10 to 30%. Similarly, an emission reduction in CO by up to 40%, and a particulate matter reduction has been up to 90%. Similarly, there is a reduction in the UHCs, and also it leads to lower carbon deposits in the equipment. So how does fuel spec work? So fuel spec actually has a very high miscibility. That is, it gets very easily mixed with the fuel. And in the pre-combustion process, the fuel spec gets completely and homogeneously mixed with the fuel through the compressed air. During the first phase of combustion, that is the actual combustion which happens for the hydrocarbons in the engine. So normally what happens is the combustion happens and the fuel gets burnt, and then there is certain amount of energy which gets wasted because the entire energy doesn't get transformed or translated into 100% combustion. That is where this iron and magnesium components of fuel spec actually stores the energy, that is the peak heat, during the first phase of combustion, and it releases that heat in the second phase of combustion, or the second half of the combustion. So magnesium, what I mentioned about the electromagnetic complementarity, so magnesium captures the energy and the iron also captures the energy. Iron initially releases that energy to the hydrocarbons, and similarly the higher spectrum magnesium transfers that energy to iron, and then subsequently iron back into the fuel. This is what leads to complete combustion of the fuel. So that is the reason why, or in a normal process, the hydrocarbons doesn't get sufficient heat for full combustion. So with this catalyst, it basically captures that peak heat and then simply transfers it to the fuel during the second half of the combustion. And hence there are no temperature hikes and the heat transfer is more evenly distributed. And as I did mention, because of its excellent miscibility, the fuel spec gets completely mixed and it has a greater surface area for transfer of energy into the hydrocarbons. So how is it used? Basically, do we require any additional equipment or any infrastructure, both on board the vessels or on shore? Absolutely nothing. It's just a very simple mixing ratio of 1:4,000. So for every 1 liter, for every 4,000 liters of fuel, 1 liter of this fuel spec has to be added. You can see the pictorial representation of how simple it is in terms of the addition. It's just a direct mixture based on this 1:4,000 ratio. So all types of fuel that goes into either the vessels or the heavy mining equipment, the logistics industries, or the fuel-fired boilers. So all of these fuels can be compatible fuels for usage of fuel spec, whether you're talking about HFO, VLSFO, MGO, HFHSD, HSD, LDO. So is it, of course, one of the first question which comes to most of your minds, I'm sure, is it safe? What happens if we mix this particular fuel into of this particular catalyst into the fuel? Does it damage the engine? Does it create any kind of other side effects? Absolutely none. So first and foremost, this average particle size of this ferrous and magnesium is less than 10 nanometers. In fact, it varies between 5 and 10 nanometers. So the metal components are less than 1/5 or to the 1/10 of the maximum EPA limit prescribed by the US Environmental Protection Agency. Hence, there is absolutely no damage to either the equipment nor to the environment. And second, the magnesium, which is there in this fuel catalyst, acts as a cleaning and a lubricating agent. And both the melting point of both these metal additives, that is the ferrous and magnesium, are very high, more than 1200 degrees. So there is absolutely no question of a melting or sticking inside the engine. And the fuel spec is just a catalyst. It doesn't interact or alter or modify the properties of neither the fuel or any other additives which are being used complementarily in the engines. Hence, there is absolutely no question of clogging or fouling the fuel purification systems, the piping systems, or any other pumping systems. So, as I did mention, basically the fuel spec is non-reactive, neither with the fuel nor with any other additives. It has a very long shelf life without any kind of degradation of its quality, either on a standalone basis or even when mixed with the fuel. It has an excellent miscibility, so the mixing of this fuel spec with the various types of fuel that we mentioned is extremely easy and doesn't require any additional knowledge or technical equipment or infrastructure. It has a very high flash point, so very easy for transportation, and it basically also improves the lubricity. What are the kind of approvals that we this particular?
If you can, I can
Yeah,
request you to kindly hasten, please. Thank you.
sure, in the next couple of minutes. So it has the approval with the US Environmental Protection Agency. And as I did mention, it is less than the 1/5 or 1/10 of the maximum EPA limit. The Southwest Research Institute of US has tested this particular product when mixed with the fuel, and it shows that this particular catalyst doesn't either degrade or, in fact, rather not even modify the fuel characteristics. The NOC has already been obtained by Wärtsilä for usage in their engines. I would also like to thank Mr. Sachin and the entire Wärtsilä team for that. And it is also approved by the GE Energy for usage in their liquid fuel-fired gas turbines. And it has been successfully used in various types of vessels, talking about bulkers, bulk containers, general cargo vessels, VLCC tankers, both in Wärtsilä and Caterpillar vessels, in Caterpillar engines. And the fuel spec is successfully tested, and all its properties have been and the results have been verified by the IIT Hyderabad. So a very quick comparison. I'll not go too much into the details since I'm already running beyond the scheduled time. So the fuel spec vis-a-vis the other additives that we are talking about, whether it is alcohol-based ethers or hybrids like fuel detergents, oxyhydrogens, and the acetones. So fuel spec scores on almost every parameter, whether it is the mixing capability in fuel, the viscosity, the working mechanism, kinds of fuels that it can be used, flashpoints in terms of transportation, and the lubricity. So with that, I'll conclude my presentation. Just a very small snapshot of our group. So our group, Mudra Group, is a multilateral business conglomerate which is headquartered in Hyderabad and spread across entire India and various other countries like Singapore, US, UAE, other Middle Eastern countries, Germany, Belgium, etc. And we pan various verticals starting from infrastructure, construction, logistics, shipping, maritime, manufacturing, commodity trading, security services, port operations, and real estate. So thank you so much.
Okay, thank you very much. Before I move on to the next speaker, I can see that users have been extensively using the Q&A. So I would request all panelists to please look at the Q&A box, chat. You will see that below here. There are about 12 questions. And I would like to, I'll come to you, the next speaker, but quickly, in the meanwhile, if I can request Mr. Vijay Arora to look at a question from Mr. Sandy Alam. It's going to be a rather wrong answer, but you can take a look at it, and I will ask you to speak about it after the presentations are done. There is also a question at 11:34 from an attendee, which I could request Mr. Sachin Kulkarni to please take a look at. is in reference to a methane slip in LNG fueled engines.
Sir, Anil W, sir, for
Yes.
the convenience of panelists,
Yes.
I have consolidated all the questions. Maybe once the panel discussion is over, if you allow me, I can read out questions so that they can pitch in.
Okay.
That. Yeah.
All right. So, so then I will, thank you. That's very convenient because, at the end of the day, people who are attending must get full benefit out of this. So therefore, I would like to now invite Shri Mukesh Kumar, who's the Fleet Personnel Manager for Bernard Schulte, to come and give his introductory remarks and presentation, if any, sir. Thank you.
Yeah, good morning. Good morning. I think we have very short time for me, but I'll not take much time because most of
you take your full 5 minutes and even more because now that the question answers have started coming in, I'm sure everybody is reading it. So we have time. Please go ahead, sir.
Yeah. So basically, I'll just talk with the existing ships which is in running, like basically future fuels that I'm talking about 2030, 50, and I'm sure with the struggle, everyone will achieve that. But present scenario, how to decarbonize to a minimum the present ships which are running, because these are conventional engines and few electronic engines are already in the market. The dual fuel engines are also there. We BSM managing few dual fuel engines, which is LNG on the long voyage, and then slowly we are coming on whatever minimum we can do to with the environment. So energy efficiency technology in the present marine sector. So basically, if we all the ship owner, the present scenario, if you look at it, I have few points like the first one is this already, I think one of our panelists have already told this thing, that air lubrication system. Then I have wind assisted propulsion, flatteners, rotors, kite and sail propulsion, marine battery system, that is energy storage and all, waste heat and energy recovery. Then EGCS, like most of the ships, I think we have installed it, that is exhaust gas cleaning system. Then we have a efficiency of the propeller retrofit, then efficiency of the rudder retrofit, existing system equipment auxiliary saving technologies, then shaft generators, then engine tuning, trim optimization, coating and anti-foul evolution, cold ironing that is sure best power and all, HVAC optimization, insulation improvements. So basically with these, I believe many ships, they are not using this even if this technology are available on their ships. So if we emphasize the present managers and ship owners and technical to make sure that the ships which are running, they go through all this so that by the time the future fuels are implemented, that IMO is trying their hard by implementing certain regulations and these things. So by that time, at least we can minimize the carbon level in the environment. That would be a much help for everyone. And basically, in fact, I believe the Wärtsilä has already come back with that is WinGD, that is a XDF engine. So slowly, I believe everyone is trying their level hard. And I think rest of the things, I think my panelists have already told, so no point repeating the same thing. Okay, thank you very much.
That was super quick, Mukeshji. Thank you very much. You are probably going to be instrumental in getting us back on schedule. So before I, jump on to the questions, this I think it has been extremely helpful even for me, and I'm sure the next few minutes of question answer session, what Mr. Ram Prasad will conduct will be of some use. I have a few points that need consideration and need the attention of all. The first and the foremost point that needs to be spoken about, and which I did not see the other speak on, is the cost of getting all of this done. Now, this is going to become a major issue for ship owners. Perhaps not so much for the larger ones, but definitely for the medium size and the small sized owners. I think there is a need for us to sit down and assess what will it cost even somebody such as a Great Eastern, or even somebody such as a small ship owner who probably owns a mini bulk carrier or a barge. And Bosab, I am going to ask you soon after this to let us know whether IMO, since you participated and represented India for several years on this, whether IMO has been able to touch on this issue. But I will come to you very quickly, sir. The other issue that I think we all need to bear in mind is, while all of these technologies and countries are willing to come forward and provide technology transfer, quite candidly, I have not yet seen any country coming forward and saying, I will give you this technology, pay me after 10 years. And I am not sounding unprofessional here. The world is ostensibly working towards making this whole space a green space. And yet commercial considerations seem to play an important role in all of this. And surely commercial considerations should play their role where necessary. But I think if we are all talking about some kind of a lofty objective of achieving reduction of carbon, I think there is a need, and our Prime Minister also touched on this in the past COP, if all of you heard his speech. And there is therefore a need for a technology transfer to be accompanied by transfer of technology and IP on a long-term basis, where the small ship owner is able to benefit out of this new technology that comes in, and they are able to comply. I would also draw attention of everybody to the finding of IRS, which Mr. Vijay Arora touched on in his presentation, where 90% of the vessels will not meet EEXI. Arora Sahab, I would like you to also touch in the next few minutes, how would a ship owner go about doing this? And in that same context, both Sahab, the experiments of Great Eastern, I know that Great Eastern and Sanmar, these are two of our member companies who have taken some steps in biofuels and hybrid fuels, etc. So I would like to also request you, sir, to also speak. I would also very importantly, Basim Saab, you have drawn on the issue about seafarers awareness. And I would also like to take this opportunity to let you know that this is exceedingly important, the training of the seafarers, making them aware of the new systems, and no doubt MSC is a world-class company because they have people like you thinking on these lines. Lastly, I would also, and this somebody else also I think asked in the chat, and if Mr. Kulkarni, if you get the time, if you can also touch on, when I got into shipping, one of the things that we used to do, we used to operate container ships, we had these power packs, which used to be put on board for the purpose of, say, our reefers or something of that sort. Is there a role for power packs in propulsion, etc.? It may sound very silly, throw the question out of the window, but this comes from someone who does not know. So with that, I would hand over the floor back to Ram Prasad ji. Will you take over, or should I ask Mr. Arora and Mr. Bose?
First, whatever issues you have raised, let them complete. Then we have time for questions.
Okay. Okay. So I would invite then Mr. Bose first, then Mr. Arora, and then Mr. Kulkarni to kindly give your comments. Thank you.
Okay. Thank you, Mr. Devli. I would respond to your question specifically. You asked about that in the IMO rulemaking process, is the issue of cost impact on ship owners are being taken into account, and what kind of cost is going to come? Okay, it's, now the initial strategy, the answer is yes. Answer is yes. In the strategy that is being revised now and has to be completed by 2023 to decarbonize international shipping sometime around middle of the century. The date is highly debated now there. So there is an element in this IMO GHG rulemaking process, impact assessment on states. That means that is there going to be an adverse impact on socioeconomic condition of states? In that case, that rule should not go forward, or it has to be addressed. That means so that element is there. And during this process, all the member states are working that how feasible it is and what kind of cost impact it will have, and so that the reduction strategy can be framed accordingly. And cost impact is going to be there. I just want to clarify one doubt, because since we are talking about decarbonization, and some may be aware and some may not be aware, there is maybe confusion. Methanol, we are talking about methanol, we are talking about hydrogen. Huge amount of methanol is available now, so is hydrogen, and it is being used for industrial purposes. But these are all procured from fossil sources. And fuel consists of carbon and hydrogen. So these are either of these or both of these are required to produce a fuel. So when you make a zero carbon fuel, when you produce or manufacture these fuel methanol from a feedstock which is sustainable, for example, biological sources, or splitting water with electricity and producing hydrogen, capturing carbon from funnel or atmosphere, and then combining together, and you have a methanol, that's the zero carbon fuel. And this costs money. For example, today the VLSFO cost is somewhere around, food prices have gone up, so $750 per ton, and methanol produced from renewable sources will be $2,000. So there are talks about market-based measure. It's under discussion in IMO that you have to put additional cost on fossil fuel to make these things comparable, to make it. And there is a lot of political attenuation on this particular issue, and we will see how it goes forward. So for the shipowner side, with respect to the challenges, huge amount of challenges exist. Ricardo, a consultancy firm which worked on behalf of industry associations, they presented a paper in the last MEPC where they have identified 120 challenges. Many of the challenges has been covered in the previous presentations, human training, safety, then containment, and around 260 research projects are going on. So, and also, we are, as shipowners, we are dependent on the shore infrastructures. 87% of investment to decarbonize shipping has to happen on land. That's going to happen on fuel production. How do you produce that methanol to split the water and produce hydrogen from electrolyzer? You have to get the power from renewable sources, which wind power or solar power. So investment in all those. So ship owners can't do it alone. Today, a car owner, there are rules for car manufacturing standards. So car owner, he buys a car which is complying with the rules, and government is putting up charging station all over the world. But for ship owner, it is different. We are being asked that, no, you must comply with decarbonization, and there is no rule on fuel producers. That, okay, on this date, this should be the fuel standards. The carbon intensity should be lower. It's not there, it's our, so that's the problem here. And we need collaboration of every sector of the industry. Fuel producers, engine makers are doing it, we know, and shipbuilders. So all these, it's required. And another thing, so yes, I suppose I have answered your question with respect to the cost, and and willingness for cargo owners to pay higher freights. Today, if you have a expensive zero carbon fuel, but For example, there are ship owners who are making methanol-powered ships running on renewable fuel. It's higher cost. And then if he doesn't find the charterers, then what does he do? He's got a dual fuel engine. He will run on normal fuel and not the expensive fuel. So charterers' willingness to pay the extra freight cost. And coming back to the second part of the question, that what the companies like Radisson, etc., are doing. So we are doing for about last 9 years or so, we have been doing various things like retrofitting propulsion pre-swilled devices, then hub vortex removers, and very low, for us, maintenance of the hull is very important. So we apply expensive high performance coatings, which keeps the hull clean so the fuel consumption is as least as possible. Then we are replacing all the traditional fluorescent and halogen lights with LED lights on our ships. And we have the software, in-house built software from which we can see the hull condition. And any hull getting foul, we get the indication, so we get it cleaned very quickly. And propeller polishing 6 to 9 months, and biofuel trial, we are going to do it very shortly. We have identified one ship to do that trial. And we always looking out for new technologies to fit on our ships. And we are looking out into the market and into the sea, how the renewable fuels, the lower carbon fuels come into the market, because we are in the tram shipping, and bunkering facility is absolutely essential for these kind of fuels. So we are always on the lookout for new kinds of fuels. So that's all from my side. Thank you.
Thank you, sir. Thank you very much. Aurora, sir, if you can quickly touch on what Indian ship owners, or what those 90% should be doing. Sir, if you're speaking, you're on mute.
Just a minute. Okay. I think I was muted basically. That is.
We can hear you now. We can hear you.
Yes, sir. So this we are talking about two things basically. First, the basic requirement for a ship owner to continue his existing ship to operate is EXI. That's the first point. CII will be coming later, but CII is also inbuilt into the EXI, what I said. So for the EXI part, as I said, that whatever ship we have calculated for these 40 vessels, which are still not meeting, as I shown on the screen, the EPL will help them to achieve reduction so that they can attain EXI, can come to a value lesser than the required EXI. Only thing is that they need to see that whatever speed reduction which will take place in the range of 5 to 12% of 15%, that speed is going to be acceptable to the charters, and then they can achieve that, they can have their attained EXI met to the required EXI. Suppose in such a certain cases where the attained EXI still does not meet by applying the EPL basically, then in that case there are other measures which they need to look into, which are simple in nature, like we said, the use of propeller boss tap fins, or they can use some duct around the propeller. These are simple methods, or if in case the bulber is not fitted, basically they can fit that also. And after fitment of that, these are energy saving devices, which I said, the CFD analysis can be done to see that the V reference can be obtained, and then we can calculate the attained EXI basically. So the ship owner needs to understand 2-3 things basically. EPL reduction is known to him, how much he can have, and whether attained EXI is coming equal to or less than the required EXI. If it is not, then he has to do something, and that he should do before the vessel dry dock. Now we are already in 2022. If the vessels are going to be dry docked this year, and he has already calculated that, and he finds that EPL is not helping them, he needs to see that what energy saving devices can be fitted now so that he can achieve it. Otherwise, it will be difficult for him to obtain the energy efficiency certificate, basically. Second part, I said that while the owners are looking for EXI, they need to also start thinking about the CII part, basically, because CII is something like, as it is an operational efficiency. In India, we are running ships which are old, and it is very difficult, and it is not easy to see that how the operational efficiency can be improved year on year, which the IMO expects from these ships. So in that case, my request to all the ship owners will be that when you are calculating the EXI and the CII, try to see that if something needs to be done on the EXI part also, that means if any other energy saving devices can be fitted, which will help you tomorrow to have a CI, improved CI, please do that basically. Again, this combination of calculations we are able to do for you, and we are doing also for ship owners. We are telling them what to be done, and this exercise can go on. They need to think about two things. If the EXI hasn't met, but the operation efficiency they want to improve a later stage, that also can be done. Let us say dry dock is going to fall due next year, but you have met the EXI by EPL reduction. Don't worry. Next year, you can fit some energy saving devices at the time of dry dock so that you stay in A, B, C category, the CII part, so that your vessels can continue to operate for the period of at least 2026, because 26 onwards, we don't know the reductions which are available, and these reductions will be decided only in the year 2026. So I think I have been, that's what I wanted to share with the people on the EXI part.
Right, thank you, sir. Kulkarni Sahib, if you have a quick comment on power pack, or
Yeah. So there are
so
there are a couple of points I could see there. One is power pack, and one was on the tank size and capacity. Let me quickly touch base on both of these. So as far as I shown, basically, when it comes to the existing engines, whether it's a diesel engine or whether it's a dual fuel, multi-fuel engine, so typically there is a potential upgrade possibilities there that we can improve the efficiency of these engines via upgrades to power pack. If it is diesel engine, then we can look at the power pack upgrades, fuel injection system modification, and certain changes in turbocharger. So that's for the diesel engine. If you look at the multi-fuel engine, so there the fuel injection system anyway is taken care. Then what you're looking at typically is an upgrades to the power pack and the turbocharger. So yeah, it is possible to upgrade that as such. So that's an answer to the power pack thing. The second point on the tank compromising the capacity, yes, it's a very important aspect and dimension. When we look at the characteristics and properties of different fuels, it's important. If you look at ammonia, we're talking about the corrosivity and toxicity. Typically, when we look at LNG, we have these nickel alloys tanks, but when can ammonia take that? No. So then we can look at the readiness by having these stainless steel tanks already fit in, so that you are ready. So one is the storage, and the second is the basically the treatment to it. And when we look at the decision on the capacity, it's important to factor that in the design stage itself. Again, there are various segments in which you operate. If you're looking at short sea shipping, then there are a lot of options possible, because then you can have the smaller tanks having the possibility of bunkering. But looking at this hydrogen and ammonia, when the endurance days are more as such, so from that point of view, short sea shipping, it could benefit. If you're deep sea shipping, then it could be a bigger tank needs to be installed. So all this factor needs to be considered while we are designing the vessel as such. And that's why we recommend that while you can build a vessel with a dual fuel engine today, but then you can already accommodate the tank material and the capacity at this stage, so that you have a least modification which will be required to be done subsequently.
Okay, thank you. So over to you, Mr. Ramprasad.
Okay. Thank you, sir. So there are some questions and there are some comments. So what I'll do is quickly run through the questions first. And I suggest the speakers, the panelists themselves figure out who would be the best suited to answer the question. The first question is Nilesh Tucker. When calculating EXI for a vessel, if the vessel is using LNG as fuel, or methane slips addressed?
So I'll answer this question if you don't mind, sir. I'll answer this question. So currently it is, I'll say the answer is no, sir. Currently the answer is no. Only thing what is being done, EXI will not be impacted. If in case you want to address the methane slip, there are some combustion efficiency can be obtained where you can improve the combustion and reduce the methane slip. That is the technology can be used, but that will impact only the CII part. But the EXI part will not be. Right now, there is nothing on this issue.
Okay. Guneet Bandal. how is the use of biofuels taken into account when calculating attained EEXI? In case a vessel is unable to bunker biofuels due to non-availability, how does it affect its compliance with EEXI?
Can I answer that, Mr. Ram Prasad?
Yeah.
Okay. Currently, the carbon footprint of fuels is considered based on tank to wake. That means on the ship, whatever happens. It doesn't take into account full life cycle of the fuel. That means from production to bringing it, processing, etc., etc. So burning a biofuel, there is carbon and there is GHG emission. So you don't get the benefit of it being a sustainable product. That is why in IMO now full life cycle assessment guideline is being developed so that you take the complete carbon footprint from fuel production, extraction to propeller, complete. So answer is that some marginal benefit may be the CO2 emission. So they will go by there is carbon in biofuel and that will be taken into account in the calculation. Thank you.
Thank you. This is an anonymous post. Considering methane slip effect in LNG fuel engines and that methane has a massively higher GWP compared to CO2, will LNG continue to be a viable alternative for reducing GHG emissions?
Yeah, I can take this. So today, if you look at Wärtsilä, we having more than 2 gigawatt basically worth of technology in the market, and where the methane slip is just less than 1 gram per kilowatt hour as such. And there are, as Mr. Arora said, that there are technologies which are possible to looking at the combustion efficiency there. So typically, when we say we are running fewer engines at higher load, is preferable than running more engines at a low load as such. And again, certain hybridization also can help the process. So yes, it's a topic which has been well addressed, and we have technologies today to take care of that.
Thank you. Sanjay Kelkar, how benefit of technology, example PBCF, can be qualified by class/RO when used in conjunction with EPL to arrive at EEXI value for the technical file? What if such changes are made post 1st January 2023 during scheduled docking?
Yes, I'll answer this question, sir. The question in respect of talks about post January 2023. And the post January 2023, whatever impact they want to do, in that case, they should have definitely ensured that EPL has resulted in obtaining the attained EXI as less than the required EXI. And the impact of the technology is that we can use CFD analysis to see that the CFD analysis will help us to what extent the impact is there to reduce the resistance of the ship, so that it helps us to calculate the V reference. The issue starts with the V reference is not available once the energy saving devices are superimposed on the ship basically, and we can calculate the V reference without going for sea trials basically, because sea trial is again you are going to carry out and burn fuel and then calculate, but V reference can then be done with using the CFD analysis. That is how the technology can be used to determine, and we can determine the EXI. But the question which was raised was after January 2023, but you have to ensure that you can use it provided you have met the EXI before January 2023, so that you don't have to think of, you can always use this, which will be useful to you at the time of CII part. It will improve the operation efficiency.
Thank you. Question from Mr. Surendra Roy. I would like to know comments and views of ship owners or stakeholders on how to deal with emissions when vessel is actually doing no cargo transportation, when vessel is on ballast leg of the voyage, doing tank cleaning, waiting at anchorage, or is at berth.
Can I answer that question? Because we represent that particular sector. Now, this issue is being discussed in the correspondence group, and I can inform some issues have been taken into account as of now, and it will be only finalized in next MEPC 78, which is in June, July this year.
June.
So before that, it cannot be said for definite. But for definite, anchorage stay, if you have, that is, will not be taken into account in deducting the consumption from CII calculation. Bad weather also will not be taken into account. But cargo heating, yes, that will be is on. So there are certain elements like this which are still on, but this we will only know for sure after at MEPC 78. Thank you.
Thank you, sir. This question, how important is ammonia fuel for marine industry?
I think who will use this?
Vanil Devli, sir, is there? He is only batting for ammonia.
Okay,
No. I am only batting for what is good for a ship owner. But I will leave it to both sir to talk about this.
yeah, ammonia is one of the zero carbon fuels, which is very much being considered. It has got advantages and disadvantages, toxic safety issues. So, I mean, it's too short a time to describe everything. Okay, thank you. But it is one of the important ones and being looked at. Thank you.
I will just add one point, Ramprasadji, with your permission. I think Mr. Sachin Kulkarni touched on this, that one of the issues that will decide what will be our future fuel will be what is convenient for the country and what is also politically pushed. So this is something which I think is, at least I think it's a very, very important point. Each country will push an agenda of fuels that will be convenient for it to produce and cheaper for it to produce. So that I think will be a point that we have to consider.
Yeah, and one more aspect is that we also see competition for ammonia from the other industries as well. So
okay.
That aspect also will come.
Sir, we need to end this session maybe in the next 2-3 minutes. So I have last couple of questions. One is from Rupali Joshi. Alternate fuel storage is also a big task. What facilities required for their storage, and can it be stored at ambient conditions? What specific gravity need to be maintained and used? It commercially needs infrastructure. As of now, where are we? This is again, I think, a big question.
So maybe let me attempt to address this. So basically, as I talked about, that fuel gas storage and supply is very important aspect of this. And then each fuel will have its own things. So today we are talking about, as I mentioned earlier, that the tanks for ammonia, that is steel tanks, because it cannot be used, the tanks which are given for the LNG ones as such. Similarly, we have to also look at the flammability when we talk about hydrogen, and then what kind of a pack needs to be prepared, manufactured. So all these dimensions will come depending on what fuel you're using, and then what kind of a characteristics you need to address. So it will vary depending on the fuel.
Thank you. The last set of questions are to Mr. Jitendra. I want him to note down and answer in single go. So how does fuel purification purifies affect the few components, Fe and Mg concentration, that is one, it refers to fuel spec product. Then will fuel spec give us credit in our EXI and CI? What is the effectiveness of on biofuels and the HSE related issues in hand? Of course, cost is something they have asked. That would be best shared one-on-one, I believe. Yeah, quickly, Mr. Jitendra.
Yeah, thank you. So I did mention that the fuel spec doesn't either interact nor react with either the fuel nor with the any other additives. So it is basically just a combustion catalyst which transfers the heat energy in a much more efficient manner so that the unburnt hydrocarbons are completely reduced. So to that extent, there will be absolutely no impact on the any other additives, including the purifiers. And the second part with respect to the biofuels, again, you must have seen that the fuel spec can be used with a wide range of fuels, starting from VLSFO, HFO, HSD, HFHSD, MGO. So the impact is the same or more or less the same on biofuels, that it ensures a complete combustion of the hydrocarbons, including the biofuels. Now, from the HSE point of view, it is a non-corrosive, non-reactive, and a high flash compound, and hence it is absolutely safe in terms of its usage, in terms of storage, and then transportation. But of course, good practices have to be followed with like any other compound that, for example, we should take necessary measures in terms of avoiding spillages, etc. But otherwise, there are no significant HSE risks in handling fuel spec. The last point which I want to also discuss with, or maybe also pose a question to Arora Saab, is that yes, fuel spec definitely reduces the amount of GHG emissions ranging from NOx, CO, CO2, soot, and unburnt hydrocarbons. So there is a definite reduction. So we believe that it should lead to a reduction in or the improvement in the rating. And we would also request the views of Arora Saab with respect to the CII as well as EXI ratings on this.
Yeah, this in the use of fuel spec, as you rightly said, that it is going to improve the combustion efficiency. And from that point of view, it may not impact the EXI part basically, but definitely it will impact the CII part, because once the efficiency is better, the fuel is burned, I'm getting more power from the same fuel. So that means I'll be burning less fuel to use get the same power basically. In that way, indirectly, I'm getting an improvement in my CII ratings basically. That is the advantage you will get, but not on EXI part.
Yeah.
Okay. Thank you very much, Anil Devli, sir. That's the end of Q&A. What questions I have?
Right.
We are 5 minutes past our scheduled time. Not bad. So I leave it to you to conclude the session so that the next session panelists are already there.
Yeah, so thank you very much. I think we have kicked off a session where I do not know if we have been entirely successful, but the attempt has been to try and disseminate information, ensure that those who were listening were able to benefit out of this. We are aware that this is a minefield. You know, one has to talk technical as much as one talks about these issues generally. But we do hope that we have been able to convey a few thoughts, generate a few ideas, and generate interest in this, so that in time to come, this very, very important topic is going to get the attention of policymakers and all of you within the industry. Once again, I would like to thank Mr. Bose, Mr. Vijay Arora, Captain Basin, Mr. Sachin Kulkarni, Mr. Jitendra Nimagada, and Mr. Mukesh Kumar, and also Future Fuels for the effort that they've taken in setting this up. And we are looking to more and more these kind of sessions coming in. Of course, there's a section that follows ours, so I'm keenly going to listen to the speakers that come into the next session. Once again, thank you very much and have a wonderful day.
Thank you very much, sir. On behalf of Future Fuels, I also thank all the panelists, each one of them by name, and especially moderator, Mr. Anil Devli. Thank you so much. We continue to continue this dialogue through our magazine, and maybe we will be reaching out to you with further questions that we are getting from the stakeholders. And also we encourage you to share with us updates and articles and interviews, so that we can be a platform for disseminating this information. With that note, I request the panelists can still continue to be logged in, maybe mute their video audio. The panelists for the second session are invited to be visible on the screen. I can see Mr. Indranath Bose is there, Jaya Kumar, and Mr. Christine Mogensen has joined, and Captain Rahul Chaudhary and Mr. Pawan Kumar. Welcome to you, sir. Mr. Girish Sriraman. So I will quickly I can't see this. Just give me a second, Mr. Bose. I'm just trying to.
Sure.
So can you see my screen? So I was just trying to introduce the panels. So we have Captain Rahul Chaudhary, who is the Managing Director of Veritas Petroleum Services from Singapore. Welcome to the panel, Captain Rahul. Then we have Mr. Pawan Kapoor with 4 decades of experience in the maritime industry, former head of International Maritime Training Center and CEO of Tolani Maritime Institute. Now he has founded this ISF group, which is involved with training, e-solutions and applied research. Then we have Mr. P. Jairaj Kumar, who's the, am I audible?
Yes, we can hear you. We can hear you.
So we have Mr. Girish Sriraman, who is the Area Manager Maritime for India, Bangladesh and Thailand from DNV GL Maritime. And we have Ms. Vinita Venkatesh, who is the Managing Director of Ocean to Door Private Limited with 2.5 decades of experience in the shipping industry. Then we have Mr. Christine Morgenstern, who is the Superintendent Engineer Marine from MAN Energy Solutions. He is joining from Germany. And then finally, let me introduce our moderator, Mr. Indranath Bose, who is the advisor to the Great Eastern Shipping Company Limited. Thank you, Mr. Bose, for your patience and accepting to be on both the panels. Now you have the responsibility of moderating this session. I hand over the session to you.
Thank you very much. A warm welcome to the second session. So we have glittering personalities here, all very well known in the industry. Mr. Ramprasad has already introduced each one of them. So what I will do, I will continue with the format of the first session, where each of the panelists, they gave their comments over 3 to 5 minutes. So I would put it as 5 minutes. And then in the second, I will come back with further questions. So first, I request Captain Rahul Chaudhary to give his remarks.
Okay. Thank you, Mr. Indra Bose. Yes, it's a pleasure to be here to attend this Future Fuels webinar organized by Ramprasad and his astute team. So thank you very much for this invitation. My first thought with Future Fuels is that we should not forget where we are with existing fuels, primarily because this dominance by existing fuels in shipping will be here with us for quite some time to come. Now, international shipping uses more than 300 million tons of this fuel every year, which powers more than 55,000 vessels out in the oceans as we speak. So this conversion is a massive task ahead of all of us, as rightly mentioned in the earlier panel discussion as well. As Mr. Anil Devli said, it's quite a minefield, and I would say that's a mild word. The IMO regulations for reducing the sulfur content in fuels to 0.5% was implemented in 2020, as we know. But this was understandably completely overshadowed by the emergence of the COVID that year. In fact, shipping adjusted to this change well enough, primarily because extensive work had been done over the earlier 2-3 years leading on to 2020. So the value of trial and error programs is certainly important. The existing marine fuels are now dominated by what we call the very low sulfur fuel oil, or VLSFO. They are not without operational and technical issues. These can exist in many forms, and it is important that they continue to be effectively managed by ship owners and operators. Because if you do not, you will reduce efficiency and increase your downtime. Existing bunker fuel hubs also play an important role as to where this fuel is bought and sold. Presently, the top 5 hub ports in the world are Singapore, Fujairah, Shanghai, Rotterdam, and Busan. This is important because the key hub ports for decarbonization of the future, what we may call the green lanes of the future, could well follow this trend. So how these large hubs ports evolve is important. In this context, where India port stands is important to keep in mind. Presently, India's portion of the global bunker or the marine fuel share is very small at about 2%. My second thought is on the options available for us as future fuels. There's no panacea for the future, and all future fuels come with its own pros and cons, be it ammonia, methanol, or hydrogen, etc. So for example, whereas they can reduce the CO2 emissions by 95 or 100%, they come with various other limiting considerations like safety. Ammonia is highly corrosive in nature, and methanol has a very low flash point. For those who may be interested, methanol's flash point is very similar to gin. I mean the drink, gin, because it's about 10 to 15 degrees centigrade. Both have energy densities, half of existing fossil fuels, so you'll need to have much larger storage capacity. So there's no free lunch. And none of these are ready today, as this is very much in the discussion and development stage. So as far as the mass use is concerned, one area of interest we see in the short term is in biofuels. This has picked up considerably, especially last year, and does offer us interesting decarbonization options as a drop-in fuel, as it needs no retrofit and can pretty much be used as marine fuel with existing ships and engines. Yes, there is talks of sustainable biofuel, but this is changing with the second and third generation biofuels, which are not necessarily crop-based. Lastly, for decarbonization in shipping to succeed, there is a need for creative collaboration, robust R&D work, and a regulatory framework that encourages and supports such a direction, be it in a port or a state or a country level. Singapore has all 3 in 1, and in fact can offer interesting ideas and works in progress in this respect. Thank you.
Thank you very much for being within the allocated time. So now I give a request Mr. Jairaj Kumar.
Yeah, thank you, Mr. Bose, and thanks to Gateway Media. So while a lot have been said about reduction of GHG emissions from ships, there is very little which is talked about the port segment, which I probably would like to represent to the forum. As we're all aware, IMO is the regulator for ships for reduction of GHG gas emissions. Unfortunately, there is no regulator for the port segment, and ports are equally responsible for reduction of the GHG emissions. Member states have signed the MEPC 74 resolution, which talks about cooperation between port sector and the ships to reduce GHG emissions from ships. There is nothing which talks about the reduction of GHG emissions from the port segment. They have identified 4 areas. One is development of offshore power facilities in ports, preferably from renewable resources, provision of safe bunkering facilities of low carbon or zero carbon fuel, promotion of port incentives for ships causing low emissions, and optimization of port costs. Having said that, India in specific has a few action plans which have been announced. One is, of course, the India Maritime Vision 2030, then the National Action Plan, then key interventions and green initiatives to support the National Action Plan, and the commitments which our country has made at the COP26. In fact, in the National Action Plan, what has already been included as policy initiatives is to have just-in-time arrivals at ports by 2023, and also port-based incentives for low-emission ships. In the infrastructure segment, they have identified battery charging stations at ports, bunkering stations for LNG, ammonia, and hydrogen. And in the technology and solutions segment, they have identified shore power to all by 2023. So these have been the action plans which have been initiated. But having said that, as a brief introduction, I head Ocean Sparkle. We operate in about 30 ports across the country. We are a port service provider. We also operate in a few international ports as well. But sorry to say that although initiative says that by 2023, some targets have to be achieved, there is very little which has been started as yet. In fact, we run and operate tugboats in many ports across India, including some of the LNG terminals in India. And our efforts to bring in LNG fuel tugs, even at these ports, has not met with much encouragement. So there is got to be a regulator for sure. First and foremost, there has to be this thing to measure the emissions, which is not yet in place. And secondly, as I said, there has to be an incentive to convert. And also, I mean, for a fact, all these measures would obviously mean increased capital cost, which necessarily has to be supported in some form, like a viability gap funding or something, for us to really look at measures to reduce the GHG emissions. With this opening remarks, I'll pass it on back to the chair, where I'll be open to further questions on the segment. Thank you, Mr. Bose.
Thank you, Mr. Jairaj Kumar. I mean, you identified a very important issue about the port sector. They play a major role in shipping decarbonization, just-in-time, bunkering facilities, and all the other issues you mentioned. So thank you very much.
So you're muted, sir.
Oh, sorry. I thank you. I will request Mr. Pawan Kapoor to give his initial remarks. Thank you.
Thank you, Mr. Bose. Good afternoon to everybody. And at the outset, would like to thank Gateway Media for inviting me for this panel discussion. GHG emissions, as we understand, is something which is global. A limited perspective perhaps cannot find us the right solutions. Because GHG, the way IPCC 6 reports talks about, is going to probably even affect our existence in many parts of the world. So that's why while, yes, regulations are to be there, we are working towards new fuels, but the awareness about the seriousness of the situation needs to be really brought down to all the levels of our society in general. And unless we do that, probably we'll not find the right solutions. We have been involved largely with the training and research activities for last 17, 18 years. And we also hold a confluence which promotes research. And we see the need for authentic data, because as Mr. Jairaj rightly mentioned, if we really want to reduce the emissions by by so-and-so year, by so many percentages, we need to have robust systems of measuring the emissions. And so what is needed is good measurement. What is needed is awareness at all levels. And that awareness, perhaps, though it is difficult, has to go beyond the regulations which are imposed on us. I mean, as human beings, we have to see what is really good for humanity as a whole, what will ensure that we exist, or rather we coexist along with other forms of life that is there. And that's why, perhaps as we discuss further, even the new fuels, which is so important, because the existing methods will only be able to reduce the to a certain extent by improving the efficiency, so on and so forth. As we explore new fuels, we will have to ensure that we find fuels and extract to an extent where everything still remains sustainable. So with these opening remarks, I would thank you all once again, and probably will be able to share more thoughts down the line. Thank you, Mr. Bose. Thank you.
Thank you. Thank you very much. So next, I will request Mr. Girish Sriraman to give his opening remarks. While I will, to Mr. Christian Morgensen, in your case, I will make an exception. I mean, I know you have a presentation material and you can't break it up. And so in your case, I would allow 10 minutes to make your presentation next to after Mr. Girish Sriraman.
Thank you, sir. Well, I think quite a few of the comments have already been given by Captain Rahul and Mr. Jairaj and Mr. Pawan Kapoor. But so what comments I'm going to give is sort of largely echoing what their sort of sentiments. So just to, come back the situation we are in, as Mr. Rahul had mentioned in the beginning, we were all patting on our backs that we managed to get out of this 2020 sulfur regulations. But, before that got over, we are already now looking at these decarbonization requirements coming in. I think the enormity is that, possibly that, as we look at the past, generally we would have 20-year gestation period, where regulations would be discussed and then adopted, but that's not the case anymore. We are now talking about within a period of possibly 1 to going towards 2030, we are talking about steep what shall I say, carbon footprint reductions as far as ships are concerned. Of course, so that means we have to basically, we are sort of forced, when we are talking about regulations perspective, it is being more like a lot of learning feedback mechanism that used to go into making of the rules is not a luxury in this case. So so that means we have to have a huge collaborative approach across the board, as Mr. Rahul had mentioned. We are talking about regulatory bodies, designers, manufacturers, shipyards, ship owners, charterers and financial institutions all have to come together to make this happen. Of course, when we are talking about going to the nitty-gritties, we are, of course, talking about several portfolio of fuels, towards meeting the 2050 targets. It's not like we are looking at one particular fuel and decided that that's going to be the way forward. We are talking about biofuels, methanol, ammonia, LNG as possibly a transition fuel, fuel cells, and hydrogen. So when we talk about methanol and ammonia, which are sort of touted as possibly the biggest ones, or possible bigger, which will have a bigger stake as far as marine fuels are concerned in the future. Both are coming with its challenges, and as Mr. Rahul rightly put in, possibly methanol is a little bit more easier to transition into as a fuel, but then there are availability issues. But having said that, it also has got it has got a low flash point and it's toxic. So there are technical aspects that have to be taken into consideration, and more importantly, I think the aspects are related to human element, as Mr. Pawan had addressed. Are we there, when it comes to the training related to handling of these fuels, how the bunkering aspects have to be taken into account? These are all, what shall I say, quite a lot of things to be done in pretty short span of time. Then, of course, organizations have to start gearing up. I'm talking about shipping companies and managers, charterers into making the fuels available, and have they taken into account that all these management of change aspects are addressed and the risks are addressed properly. So quite a lot of, we are talking about a wholesome systemic approach, looking at human, organizational, technical factors, which have to be addressed if we have to succeed. So largely, that's the point that I wanted to make. So over to you, Mr. Klas.
Thank you very much. Thank you. Class plays a very major role in this transition. So thank you very much for your initial comments. I'll come back to all of the panelists with my questions. Now it's over to you, Mr. Christian Muggenson. You can make your presentation. I understand you have a presentation, so please.
There you go. First of all, thank you very much for inviting me to speak to this at your webinar, Gateway Media. This is much appreciated. And we also in Main Energy Solutions find that the decarbonization agenda is very important. When we are looking at the industry as a whole, the shipping sector as a whole, then we can actually see that that we are transporting 80 to 90% of all global freights. And again, the shipping industry is contributing with approximately 3% of all the global CO2 emissions. And when we take into account how many of these vessels that we are actually powering with our engines, then we can actually say that we, to some extent, are responsible for 1.5% of the global CO2 emission. So with this in mind, then of course the journey towards a carbon-free future is also very much on our mind, and this is a goal for us to be able to provide solutions where we have less carbon emissions. And the journey for let's say a carbon-free or a less carbon-intense industry has gone on for quite some time now. We had our first MEGI, our first LNG engine in service in around 2011. And in 2012, we could see that approximately 1% of all the power ordered for vessels, for main engines, were with dual fuel engines. And and we saw, let's say, not so much movement in this before 2017 and 18, where we started to see an increase in dual fuel engines out there in the market and on order. And when we are looking at 2021, then we actually had around 30% of all contracted gigawatts was with dual fuel engine technologies. And it is our expectation and prediction that that the share will increase over time. And that is in order to have a less carbon intensive engine. In January this year, actually 50% of all new building engines ordered was with the dual fuel technology. To give us a small overview of what kind of solutions that we are providing from Main Energy Solutions. In 2011, as mentioned, we started with our MEGI. In 2015, we started the development of the methanol engines, and the first methanol engines came into service around 2016. And then it actually just increased, or the time span between we issued new technologies were reduced quite significantly. So also in 2016, our ethane engine came into service, and we started to develop our LGIP in 2018, and we had the first in service in 2018 as well. And now with the LNG market, LNG carrier market, we saw the need for developing a Otto cycle low pressure LNG engine, which where we now have 110 on order, but no engines in service yet. And our latest development is the ammonia engine. We started the work in 2020, and we expect to have the first engine in service in 2024. In parallel to all of this, retrofit is something that we have done throughout the time, where we started with Nake Lab in 2015, and then we have done quite a number of retrofits since then. So to have an overview of a more simple overview of the engines that we are providing, we have our LNG engines, which is currently offering, let's say, a 20 to 25% CO2 reduction compared to conventional fuel, heavy fuel oil, that is. Then we have our ethane engine, which is a sister engine to our LNG engine, where we have gas injection to the combustion chamber. And then we have our series of liquefied gas injection engines with the methanol engine, where we are now at the third generation of this engine, where the first was introduced in 2016, LPG engine, and then our ammonia engine, which is still very much under development, but we have committed to have the first on order in 2024. So where to go and how do we see the future? Because as we just heard, we are currently moving into a very, very interesting period where the decarbonization is a very hot topic, and is also a fast track topic, so to say. We see a lot of regulations coming into force now, both from IMO, but also EU just issued Fit for 55, which also have a great impact on how we can operate the engines moving forward, as well as we are seeing owners that are proactively would like to reduce the greenhouse impact beyond what is required from any kind of regulations. And that is because the owners now start to see that there is customers for even though that there is customers for chartering the vessels, even though that we are seeing a higher OPEX and a higher CAPEX because we are using or utilizing the new fuels, as well as we are seeing finance institutes with the Poseidon principle and others that are only interested in investing in, let's say, greener engines. We at MAN we are a service provider, so we are listening to the market to see what the market is requiring us to develop, and we are in this really trying to keep up with the demand out there, which sometimes can be difficult. So yeah, so there's a lot of inputs. What comes first, which will be the future fuel? The way we see it is that that it very much will depend on which type of vessels that you have, which freight you are on. Are you in a container line between Europe and Asia? Then maybe one fuel could be fit for you. Are you operating in the spot market with a multi-purpose carrier, a bulk carrier? Then there will be different fuel requirements. But regardless of how which fuel that will be the future fuel, then we can say that we have the solution in place already. Looking at the crystal ball, our crystal ball department is only a very few amount of people. So we are very much leaning on the big players in the market, for instance, DNV. And DNV in 2019 issued this maritime forecast where they had, I think, 10 or 15 different scenarios for the future. And whereas when we look at the end result in 2040 and 2045, then ammonia will be the predominant fuel. We do not believe that it will be so black and white. We believe that it will be a mix of all of the fuels. But when looking at the list of the possible future fuels, then we can actually say that our engine technology can operate all of them, of course, besides the electrical grid. And what comes first, and of course, this is with all of the inputs to what the future fuel is, there's still a lot of uncertainty. As of now, methanol is a very popular future fuel, so to say, but currently there's the infrastructure for bunkering methanol is very weak throughout the world. So our approach is also that we would like to be able to supply the main engine, and then at a later stage, it is possible to refit or retrofit to any given technology that we have in our portfolio. And currently, when we are looking at the reference list of conversions that we have, then we have done from conventional MEC engine to DIE, ethane engine, conventional MEC engine to LNG, DI, as well as we have done a batch of 15 vessels from MEC, conventional engine, to LGIP. Currently, we are also looking at the methanol projects. We have, let's say, some hot leads, as well as ammonia, of course, also will be possible to retrofit in the future. That was what I just had for you today. And the closing remark, we we see a high demand from the end customers, and we see it possible. And we are, of course, keen to listen to the market, what they are telling us and what the next engine technology should be. Thank you.
Thank you very much, Mr. Morgenstern. Excellent presentation. And I mean, we need assurance from engine makers because you are at the heart of things apart from shipbuilders. So thank you very much. I'll come back with questions at a later stage. So, Ms. Vinita Venkatesh, Nes, I understand you are in a very different time zone. Is that right?
Yeah, that's right. So I'm in a very cold and snowy Chicago, and it's 1:30 in the morning.
Okay, I can imagine your situation there.
Please excuse the lighting. So the lighting in this hotel is not very good. So if you will permit me, I will just quickly put up some slides in exactly the 5 minutes.
Please go ahead. Please, Yes,
so I'm going to talk to you again about fuel spec, which Mr. Jitendra has already spoken about, but from a little different angle. So I'm heading a company called Ocean to Door, and Ocean to Door is part of the Mudra Group. And we have the responsibility of the global marketing and distribution of the fuel spec catalyst. So, fuel spec is actually manufactured in the United States by some scientists. And I'm going to share with you some of the work that they have done and some of the results that they have on the trials that they have conducted. But before that, just to set the context for what we are going to talk about, we've heard a lot in this, all the comments have been resonating at the same frequency, that there is not enough time, there are a lot of new technologies, all of them need to be tried and all of them are expensive. So if you look at the picture in the lower half of the screen, what are the solutions that are available today? Most of the solutions involve high investment. And the only solution that is there in the short term, right away ready for the shipping lines, is perhaps to optimize speed. Now, all of us are aware in today's global supply chain situation, slowing down the vessel is tragedy, not only for the shipping lines who are desperate to carry more cargo, but also for the customers who are already facing so much congestion. And this is what then brings me to fuel spec, which is, I believe, a revolutionary product that has been invented in the United States. Now, these are some of the trials that have been conducted by the scientists who invented fuel spec. So number 2, number 3, number 4. That is Matson navigation on a manned B&W engine, Bahari ship management on manned B&W, and Shipping Corporation of India on a Wärtsilä engine. These 3 tests were conducted by the manufacturers when they were testing to see the results of their product. And you can see some fantastic fuel savings, almost unbelievable kind of results, which of course came about with a lot of practical trial, as well as a lot of mathematical calculation on the vessel loads and the currents and wind speeds and all of that. After that, when we were approached by the manufacturers to undertake the marketing and distribution, we have done a trial on the SSL Mumbai, again with the same fabulous results, and therefore decided to sign up with them. And now here we are trying to reach out to the industry and every stakeholder in the industry to try out the product. So we have recently, after signing up just less than a year back, done a trial on Jaldi shipping with a 7.5% reduction in fuel saving. And we have also now a trial which will take place shortly next week with the ISL Star, which is part of the Tata Group. So, one part of emission reduction is the kind of fuel that you use and perhaps the additives or the catalysts that you add. And the second part is also reduction in the quantity of the total bunker consumption, right? So I've just put here some numbers because it's finally whatever we have to do in technology with the technical departments and however we run our ships, finally, it's all about money, because every enterprise has to be economically and financially viable. So fuel cost represents a significant percentage of the operating cost of a vessel. And today, I have put here the fuel cost as $750 per ton, but it's already at $775 or $780. And with the whole Ukraine crisis happening, we can't really say where the fuel cost will go. So if you consider a 10 days in port and steaming of 20 days with a 35 tons per day consumption, we are then looking at a sensitivity analysis. If you have a 7%, 8%, 9% reduction of almost $20,000 on one vessel, 1 month, the economics is very, very startling. And even if we don't get 7%, even if you get 5%, it's a massive saving. So just to give you a quick look at how the trials are done, the dosing ratio is 1 to 4 tons. Depending on the appetite of the customer, the trial can be for 15 to 30 days, and then the data is recorded and analyzed. And this is the trial that we did on Jal Kumud, a very simple dosing on board by the vessel crew, at least for the trial. And for the emissions reduction, we have we can use these handheld machines that can capture the readings. So some questions that keep coming up from people is, we want to clarify that fuel spec is a catalyst, which makes for fuller combustion, and it's not an additive. It is not proposing to replace the working of any of the additives that the vessel's technical teams might be using right now. And it is also not going to interfere with the working of any additive. It doesn't impact the engine because it's a pure catalyst and no deposits. It can work, of course, with scrubbers because scrubbers have a different purpose. It can be used on both 2-stroke and 4-stroke engines and stored for long periods of time. And yeah, this is just our contact list. So that's all I wanted to say, just to introduce the product, and then I'll come back with any other comments.
Thank you very much, Ms. Vinita Venkatesh, and very informative and efficiency improvement. I mean, until we go into the other lower and zero carbon fuel will remain a matter of great assistance to shipping. So I'll come back with questions at a later time. So having gone through the initial remark, now I come back to the questions. So first question I have to Captain Rahul Chaudhary. You did mention about the 2020 change that happened, and you have been testing. What has been it has been comparatively smooth than what we had expected. So what were your findings with respect to fuel quality post 2020 and the biofuel part? I mean, there are biofuel tests are happening. So if you have tested biofuel, and how do you see biofuel as a solution? Thank you.
Sure, thanks, Mr. Bose. A pleasure to give a little bit more elaboration. Yes, I mean, the way we see it, there was a lot of planning, preparation, testing by owners operators pre-2020, and I would think based on what we test, I think it has been a smooth transition. And one of the ways to look at it is to say basically the IMO regulations is about reducing the sulfur content in fuels. So has that been achieved to meet the 0.5%? I would say yes, it's been achieved. It doesn't mean that there's been no issues. What our data shows is that about 3% of global fuels are off specification in sulfur. We don't think that is a huge amount of sort of default, but I think we need to keep that in mind because if that happens to your ship or you're operating the ship, then you have a dispute and an issue to handle, and that's one aspect. The other aspect, if we look at a macro level on fuel quality, as we stand today, about 6% of global fuels are off specification on one item or the other, instead of going into, and the primary reason is because the VLSFOs are blended fuels. And some of the common fuel quality issues we see with these new blended fuels, which is quite different from pre-COVID days, are issues like fuel stability, which is linked to the way these fuels are blended, which are again linked to technical issues like filter clogging, sludge formation, etc. These fuels tend to have cold flow properties, as we call it. So they need a certain level of heating, and you want to be very careful if you are, navigating in cold waters. They have what we see high cat fines or higher water levels that we've seen this year. So basically, good housekeeping is needed on board ships and the way you operate the ships, and you need to keep that in mind. One interesting aspect I did want to touch on is how do we see the distribution of these problem fuels with VLSFO so far? Very interestingly, the VLSFO problem fuels are much more in Europe and the Americas than in the Asia Pacific. I think that is quite an interesting finding. I don't have the exact reason why it's happening. Maybe it has to do with the fact that the COVID has reduced the supply chains and products are not moving across borders as much as it was before and the way it's blended. So that's, I think, an interesting observation. Going on to biofuels, yes, especially last year, we've seen the amount of tests we've done on biofuels dramatically increase by possibly 5 to 10 times that we've ever done before. There are many big ship owners and operators who've already completed a number of trials. Some of you guys who are very active on LinkedIn will have seen a message or a post by CMA CGM yesterday that they're going to trial biofuels and working together with the Maritime Report Authority of Singapore on 32 of their large container ships. And they're going to burn a biofuel called B24 because you can get biofuels from B10 to B100. And approximately what they mentioned in the article of yesterday is that they'll get a 21% reduction in CO2 emissions. And we see that with other ship owners as well. If you are going to pick up a B25 fuel, which means 25% of biofuel which has been blended in, you're likely to see about 20% CO2 reduction. It's an easy fuel to use. It complies with sulfur regulations. It has a pretty good energy value, close to a pure fossil fuel. It has good ignition and combustion characteristics. But I'm not going to say that it is sort of, it's going to solve all your problems. You do need to be careful of things like oxidation of this fuel. You need to be aware that you probably can't store it for too long. It needs to be used up quickly because of bacterial growth or cold flow properties. And I would add that a number of engine manufacturers have actually got biofuel specs and biofuel recommendations very much in place. So, I mean, from our point of view, we will probably test whatever you want us to test, but we do see a lot of activity in this area. Yeah. Thank you, Mr. Bose.
Thank you very much. Thank you. I will now turn to Mr. Jairaj Kumar, that you are in the port sector very much. And then what kind of, how do you see the port sector preparing themselves for the transition? And another question is, as a ship owner, I mean, what all the things you have done or you are looking at in decarbonization? Thank you.
Yeah, thank you, Mr. Bose. In my opening remarks, I mentioned that we haven't yet got started, but definitely there are action plans which have been made, and ports can contribute both directly as well as indirectly for reduction in GHG emissions. Directly, one of this thing is to increase the use of renewable energy to greater than 60% across major ports. I really don't know why they say major ports only, because today minor ports contribute an equal amount of cargo handling. I think that needs to be looked at. Drive adoption of multi-clean fuels like electric, CNG, LNG for port crafts, as well as for vehicles which are used in the ports for moving containers, moving cargo around. Electrification program for material handling equipment in ports, build a real-time monitoring program to track key HSE KPIs in ports and shipyards. So this is very important to reduce the GHG emissions. And these are the direct contributions which the ports can make. The second is, how can the ports support shipping in reducing their emissions? One is to provide ship-to-shore electricity for all vessels, first starting with tugboats, then going on to coastal vessels, and then exim trade vessels in a three-phase targeted manner through an intermediary who will provide this renewable energy power. Establishing LNG bunkering, ammonia bunkering, hydrogen bunkering facilities at ports. Increase the use of efficiency enhancement techniques such as ship tracking and smart lighting at ports. Use big data to arrive at just-in-time arrival for vessels at ports. And monitoring facility to check the quality of emissions for vessels in port and incentivize them accordingly. I see a question in the chat box where somebody made this thing, and of course, Mr. Christensen also pointed out that ships are only responsible for 3% of the emissions, and what are we talking about, kind of thing. Well, I do agree with the questionnaire about what he's saying, but it is not without reason why we are trying to attempt this. And everybody here will certainly agree with me that unless and until there is pressure to this thing, nobody wants to change. And in my case, the pressure is from the financial institutions and private equity investors who are, especially multilateral financial institutions like IFC and ADB, who have clearly spelled it to us that unless and until you show progress in going green, we're not going to fund you anymore. So that's the reason why we are looking at change, quite honestly, right? The second question which you had was, how are you as a company progressing with the green initiatives? Yes, we are the largest tugboat operator in the country. And we've already have identified a biofuel, which is a complete replacement for the hydrocarbon or the fossil fuel that we're going to use. We're going to test this biofuel shortly. It is from agricultural waste that this biofuel is being produced in India by a company called Green Jules. And we're going to try that fuel on our tugboats, number one. Number two, given the fact that there is a lot of idling time on a tugboat, it has been proven beyond doubt that hybrid tugs are a good answer for reduction in GHG emissions. In fact, there are recognized designs for hybrid tugs where the actual power requirement comes down substantially for the same bollard pull which is going to be required for the tugboat. So we are in advanced discussions for construction of hybrid tugs. And I do hope that the port sector till today, which has not really woken up, we are actually being sandwiched between the port sector and the financial institutions. The port sector, if it can give us some leeway, where it not only judges a tender by just the charter rate that we are giving, but by a combination of the charter rate and the savings in fuel that we can bring in, and which they can obviously, fuel is being supplied to us as a pass-through. I think we can definitely make a start in getting into hybrid tugs. Thank you.
Thank you. Thank you very much. Mr. Ram Prasad, and I suppose somebody is taking note of the suggestions and recommendations being made by the panelists. Very, very valuable in this transition. I now turn to Mr. Girish Sriraman, You are a classification society and responsible for safety, security, and environment protection of ships. So what all gaps do you see in transitioning to the lower and zero carbon fuels, and how are these being addressed from the classification society perspective? Thank you.
Yeah, as I said in my opening remarks, sir, I think we have to categorize it into possibly into three aspects. One is, of course, the technical aspects, then, of course, the human element, and then, of course, the organizational part. I suppose, when we talk about the technical aspects, it may possibly, what shall I say, you invest in money and capex, I think, possibly the easier part to handle. Of course, the challenges that are happening at this point is basically we have a wide, it's not like we are looking at one particular fuel, we are looking at several kinds of fuels at this point. Of course, then when you are talking about technical aspects, it's from a classification perspective or from a statutory perspective, then what we are looking at is basically addressing the regulatory aspects and the design aspects, looking at all the design aspects and framing the rules. Of course, as I mentioned in my opening remarks, we have generally been in a phase where we used to get possibly a 10 to 20 years of, what shall I say, a hearing phase before regulations used to come into force, but that's not a luxury that we have at this point. So when we are addressing, again, when we are talking about methanol, ammonia, or LNG, or hydrogen, when we look at the existing vessels, none of them can take on board any of these fuels, because of the flashpoint issue. Then, of course, toxicity, depending upon what fuel we are talking about. So, so the immediate aspect is if owners are looking at retrofits, maybe it may not be financially viable for most of the fuels, and possibly, yes, some of them it may be possible, but for most of them it may not be financially viable. And then, of course, the other aspects, then we are, if you are, those are aspects related to the technical aspects. Then, of course, the aspects then that we have to look into is on the competence part. I think, again, Mr. Pawan Kapoor addressed it. Are the ship staff on board, are they, what shall I say, have we addressed all the training requirements which are required to ensure that the competency is there to handle these fuels? And so, and then, of course, the organizational aspects. So quite a lot of things have to be looked into and in a sort of a broader picture. If we have to see that all these gaps are addressed and we are able to take on board these fuels in a safe manner. I hope I have addressed the question.
Yes, thank you. Now I would turn to Mr. Ramprasad. I hope what I wish to do at 1:30, I want to give 15 minutes for all the questions that are coming in the chat box. And I suppose, like in the first session, that you will handle those questions to the.
Sure, sir. I will take up the questions. Yeah.
So the question I have for Mr. Pawan Kapoor is that if you can tell us something about, I understand you are involved in a Green Voyage 2050 project of Norway, IMO, Indian government. That can you tell us about it? What is happening here with this particular project?
Thank you, Mr. Bose. While I may not be at liberty to share specifics of any discussions with the stakeholders, but I'll certainly, for the benefit of the audience, give a broad picture. Essentially, the Green Voyage 2050 is a collaborative project where Green Shipping Program of Norway is the supporting organization. Green Shipping Program, as you may be aware, was formulated in the year 2015, and they are essentially a public-private partnership program in Norway, which involves the government, the players, the manufacturers, and they are essentially trying to do studies, take up projects, pilot projects, implement some of the ideas which they are deliberating upon, and thereby find green solutions. So it's a very customized kind of an approach to finding green solutions. Now, with the help of GSP, who have supported IMO and the DG Shipping, I'm there as one of the consultants in individual capacity, along with my colleagues. And essentially, we have industry players who have shown interest in adopting green technology, with whom we are having a dialogue and trying to find out the situation that they may be in. And thereby then studies will be carried out to find suitable green solutions. Now, these solutions obviously will involve new fuels and technology, but also keeping in mind the impact that such implementation would have on the society at large, because there are other stakeholders who get impacted. Incidentally, I would just like to share something here, that even the IPCC 6 report actually gives a correlation between the mitigation measures to reduce the GHG emissions and the various sustainable development goals. Because any mitigation measure is also going to impact positively or adversely some other part, some other entity globally. So that's why in this particular project, implementation of new technology or ideas would happen as a result of a comprehensive study to evaluate what would suit in which context, basically. So that's the whole idea behind this project. Thank you.
Yeah, thank you. Absolutely, you are right about this. Sustainable meaning of sustainability, just not priority on one's issue. There are other sustainability goals as well. So thank you very much.
Thank you, sir.
I try to, as Vinita Venkatesh, so you have been involved with the 2020 sulfur cap changes, and so do you see some lessons that we can learn from that change with respect to the changes in fuel to, there's decarbonization? Do you see any lesson to be learned, and what are the impediments or you find, and what changes are needed? Thank you.
So I'm just sharing this screen now. So it appears, is it visible, sir?
Yes, it is.
So, from my experience in talking to many ship owners, technical departments, etc., time is ticking. And maybe because of COVID, we all forgot the kind of stress, urgency, and absolute chaos and confusion that everyone went through before the 1st January 2020, when there was so much evaluation to be done, and the cost implications, the most important cost implications to be considered. Right now, yes, again, the 1st January 2023 calendar date is coming up upon us, and ships, as you know, are mysterious entities. The VLSFO adoption has not been easy. So many quality issues with the fuel supply. And there was one customer who said to me, "Madam, if your fuel spec can just reduce the deposits on my engine, I'm happy. It doesn't matter whether I'm going to save money on fuel efficiency or not." So I think that there are some, perhaps we need to adopt a different approach than we have adopted in the past to new technologies, new suggestions, because everything needs to be tested, right? There is nothing that we know is for sure going to help us. Everything needs to be tested. And very importantly, the ball is not only in the ship owner's court. So in the ship owner's office, what I observe is happening is that the technical department and the commercial department. So if the technical department is, let's say in the case of fuel spec, has gone through all the chemistry, all the documents, all the exhaustive trial reports that we have, and then there is no budget. They don't have budget to do the trial. So then you have to go to the commercial department, and then we start the ball rolling again. So I feel that if we are internally more cohesive and realize that this is a common objective, of course, everyone realizes in the bigger picture, but in terms of the actual work description or the job description of each department, perhaps it can help if this changes. And also the ball is not only in the ship owner's court, like I said earlier. So many other agencies are involved, and many customers say to me that, oh, we can't test your product unless you get me an engine manufacturer's NOC. And I don't have to tell you what will happen if I go to an engine manufacturer. So I think that engine manufacturers, insurance companies, all other statutory agencies, we need to relook at the cost element of assessing any new technology. And I feel there should be a more participative approach when there is some new technology. If fuel spec, if like the inventors say, and like our tests are showing, is actually going to reduce the fuel efficiency by 10%, then it's something that everyone should be engaged in, right? It's, to my mind, it feels a little bit strange that we will spend $500,000 on retrofitting an engine for a 2% reduction in fuel consumption. And if there is a product for which a testing involves only $20,000, it is, can you give me free samples? No, to test it on my engine, it will take 300, I don't know how, very high cost. So I feel that there has to be a little bit of, like I said, a participative approach when somebody is approaching with a new solution or something that can reduce the emissions and reduce the bunker consumption. Similarly, if ports can give incentives, like also what Mr. Jairaj was saying, cargo owners again have to be participative and agree to bear portion of the cost. And in this, perhaps a lot industry associations can also support. There are many industry associations who need to start educating their members about this global responsibility that we have. It's not just about the ship owner or the shipping line who is carrying our cargo. We are also part of this whole enterprise to kind of save our world, and we must be prepared to bear part of the cost. So for this purpose, we have been, Fuel Spec, we have been doing a lot of promotion and reaching out to many markets. Largest reach out that we have done is in the Middle East, where we participated in 3-4 events just to disseminate information about this product and its promise, and to request shipping lines to on ship owners to try out the product. And then we will also be in Europe in June at the Posidania and at the Decarbonising Summit. And I request everybody who's on this webinar, please reach out to us. If we can help in a small way, whatever small way we can help, we will be very happy to partner with the industry in its effort to reduce emissions and increase fuel efficiency. So I'm going to stop this share here. So I just had one comment that I wanted to make. While we're talking about carbon emissions, Fuel Spec, it's also shown in the test that it reduces NOx substantially. Now, one of the inputs that I got from the technical director of a shipping company was that today we are keeping the combustion pressure lower in order to reduce NOx emissions. Now, if fuel spec is supposed to reduce the temperature peaks and make for a more even temperature in the during the combustion process, and thereby it reduces NOx emissions. So this could actually help the industry, because then you don't have to reduce the combustion pressure and you can allow the vessel to steam faster. Also, about biofuels, my understanding is that when you use biofuels, the NOx emissions are more. I don't know if this is correct, but if it is, then again, fuel spec can be a very, very valuable possibility for even ship owners who are planning to use biofuels. Of course, all this has to be tried. Thank you.
Thank you. Thank you very much for the information. I now thank each of the panelists for their excellent contribution and making it useful for our viewers and even individually ourselves. And I know there is question for Mr. Maukelson, so I will hand it over to, in the chat box, and it is there, I have seen it, so I hand it over to Mr. Ram Prasad. Thank Mr. Ram Prasad. Will you please take it?
Thank you, Mr. Bose. Yeah, I will just read out these questions. Some are addressed to specific panelists and some are general. So the first question is, what is the opinion of all the panelists in regards of changing the rules of construction to ensure net zero vessels will be built post 2030? Any idea?
I can address it. So, see, so IMO has sort of moved towards a goal-based approach. So they have left it to the industry, the ship owners, to come up with solutions. It's we are moving away from a prescriptive approach to, what shall I say, a goal-based approach. So so as we come up with solutions, and the spirit of what is required to be achieved is fulfilled, rules are getting framed.
Thank you. There are two questions to Christian Morganson. The first question is, would you please elaborate on the storage material requirement for the tank construction, also pressure and temperature condition for storage of ammonia as a fuel? That is the first question.
Yes, and sorry, thank you very much for this question. So, 1 second.
Yeah, please go ahead.
Yes, sorry. Yes, so ammonia, we expect to store it at in liquid phase, so that will be around minus 35 degrees. Probably here we will have some safety margin and then store it at an even lower temperature. In terms of, let's say, the tanks and the tanks capabilities, then of course ammonia is a corrosive fuel, it's a corrosive material, and this sets some requirements. However, what is a very big advantage for us in the marine sector is that ammonia is already now widely used in the process industry. So what we can do is that we can actually adopt, let's say, the regulations and the guidings from the process industry to the marine sector. So that means that we know that we will be using a 316L stainless steel, as well as we will adopt a mixture and let's say a fuel spec which contains 5% water, and that is in order to avoid stress corrosion. So in general, yes, ammonia is a new fuel for the marine sector and a new fuel for marine sector. However, ammonia has been handled for many years as fertilizer in the process industry. So with this, we can really adopt on the knowledge and know-how from the process industry. I hope that replied the question.
Yeah. The second question is, can you please say something about your newly developed low pressure MEGI engines with reference to methane slip? for your methanol and ammonia engines fuel systems, is this being designed by the shipyards or man? The cost for the engines, are they as high as the fuel systems that have to be installed?
Yes, and thank you very much for this question. So we at MAN, we designed the engine, and we also designed the specifications towards how which temperature and which pressure and which amount of in this case LNG should be supplied to the main engine. And from this point on, then it is up to the owner to select a maker for the fuel gas supply systems. That is not what we do. So this is very much dependent on the yard and the engine builder together with the owner to decide which maker they should use for the fuel gas supply system. And again, this is also very much dependent on which kind of LNG carrier you have and which kind of principle that you're using for cargo handling. The engine price, what we saw with the MEGI was that the engine price was almost similar to the reliquefaction plant for the LNG. And that was again because of the setup, how the yard decided to handle the cargo, where we would like to reliquefy a lot of the LNG. With the MEGA, the fuel gas supply system is a bit more simple because we are only requiring 12 bars of inlet pressure to the main engine. And to briefly touch upon the methane slip, because we're using the Otto cycle principle, we have slightly higher methane slip compared to our MEGI with the diesel cycle principle. However, with our MEGA, we have installed EGR as a requirement, and this will actually contribute to reduce the methane slip with around 50%.
Thank you. In fact, I have 3 more questions, but I'll come back if the time permits. This question is to Rahul. Rahul actually addressed Arvind Sharma's question, but this is a subsequent question. Has Veritas tested different sources of biofuel? I'm aware that testing to C14 bio content can be measured as done for 80 to 17 parameters. Will this, in your opinion, be required to be verified, notwithstanding BDN, etc.?
Yeah. Thanks, Ram Prasad. I saw that. What we are saying is that since the biofuels is an addition to existing fossil fuels, ISO 8217 is existing fuel quality standard. So it would be smart for one of the operators to follow that. If you're a first user of biofuel, it would be good for you to do additional tests such as FAME, which is what biofuel is made of, fatty acid methyl ester. You need to do a copper corrosion test. You need to make sure the ignition qualities are good, etc. I think in the initial phase of using of biofuels, especially during a trial phase, is really important you sort of add on to existing test methodologies just to make sure you have a good feel of what this product is, irrespective of where it comes from. We are seeing biofuels, generally they have given the notation B. So you can have B10, means about 10% of biofuel, to B100, which is a pure biofuel. What I would add, Ram Prasad, is that if I use the example of CMA CGM, yesterday's news that they're going to burn B24 UCOM. What does UCOM mean? It's used cooking oil methyl ester, done in a sustainable way. So they're also trying to, the way I see it, sell the idea that it's sort of a circular economy. You're not sort of burning crops down. So that would be my comments. Thank you.
Thank you. This question is to Mr. Jairaj, a subsequent question by Arvind Sharma. What is the standard to which shore power is being installed in ports? So this is purely from a line operations perspective. And another question is, one second. Can ports do implement any measures without the government regulations and support financially? So 2 questions.
Okay, and the shore power at ports which is being given is 50 cycles 440 at the moment. As I said, the action plan is to provide this power from renewable sources, but for the moment, it is from line sources that it is being provided, number one. Number two, without the government support, can ports do this thing? For sure. I mean, as I said, most of our contracts, the fuel is supplied by the ports, and if ports do agree to supply biofuel instead of fossil fuel, directly would this thing into reduction of GHG emissions. And as I mentioned, use of either electric or LNG or biofuel for other port crafts and transport vehicles, they can surely aid. And for all this, the government support is absolutely not necessary at all. So ports can very much do a lot, and they don't need to have any support from the government, actually.
Thank you. Mr. Bose, in view of the time available, I have the last 4 questions. Out of them, 3 are to Christian. Okay?
Okay, please.
Okay. So the first question to Christian is, NH3 as alternate fuel, what is the impact on NOx emissions?
Yes, so NH3 is of course a nitrogen-based fuel, and of course we expect that when we are combusting it, then we will see, let's say, an increased amount of NOx compared to what we are used to with heavy fuel oil, LNG, and so on. So of course this is let's say a concern of ours. As of now, we actually don't know the actual number, and that is because we have not been able to do the full test yet of ammonia. But that mentioned, FCR is available as a ambient technology for reducing the NOx. And we strongly believe that we will be able to tune both the engine process as well as the SCR unit in order to cope with the increased amount of NOx in order to be compliant with the tier 2 or tier 3.
Okay. When NH3 as alternate fuel is being used, how engine components are protected against high corrosion to ferrous materials? Do engine cylinders, liners, etc. need modification?
As of now, we don't know, but we expect so. So again, we have not been able to do the first combustion chamber test of ammonia. Once we have this in place, then of course we will have a better picture of the corrosiveness of ammonia. But that in mind, we are preparing to handle a very corrosive fuel, both in terms of what do we do with the piston crown, liners, and piston rings, of course. When we are looking at the fuel injection system, then we can actually see that we believe that we are on track. Again, this is the knowledge learned from the process industry. So for the fuel equipment system, then we have the right materials in place.
Thank you. Last question of the session to Ms. Vinitha Venkatesh. Has the fuel spec trial done for the engines with respect to the carbon deposits in the combustion chamber and the combustion equipments? That is, initial inspection before using and intermittent inspection till the next overall period.
Yes, so we have 3 trial reports, which are very extensive and detailed trials, and we are happy to share those reports with whoever has an inquiry and to dialogue on them.
Thank you. There are some comments from the participants, but of course, due to paucity of time, I cannot read out all the comments. But I thank them for their enthusiasm and interest in participating in the discussion. Anyway, I'll be sharing those comments with our moderator and other panelists, and also take note in our magazine in subsequent issues. With these comments, I hand over to Mr. Indranath Bose to conclude the session.
Thank you, Mr. Ram Prasad. So it was a very, very useful and informative session. And thanks to all the panelists once again. And thanks to you, Gateway Media, for thinking about this, your publication. When I saw the publication, I said this was very much needed now bringing this whole issue to knowledge of all stakeholders. And it's a long journey for us, a difficult, challenging journey, but we can overcome it because for our future generation, we need a place where we can live and not leave the earth like we saw Don't Look Up in that movie very recently. So thank you very much. That's all from my side. Thank you.
My pleasure, sir. So on behalf of Maritime Gateway and Future Fuels, I thank the moderator and all the panelists, Captain Rahul Chaudhary, Mr. Girish Sriram, Ms. Vinita Venkatesh, Jairaj Kumar and Pawan Kapoor, and Mr. Christian Morganson for their valuable time accepting to be on the panel. And let me tell you, at 1:50, we still have 140 participants logged in. So that shows the interest of the our industry participants to know about the fuel segments and the regulations and the challenges that are coming up in future. So thank you very much. We look forward to much more engaging sessions in future. We will be in touch with you. Thank you very much. And I thank all the participants so patiently have waited from 10:30 to 2 o'clock and participated in both the sessions. And I once again thank all the associations that have supported us, FOSMA, CMMI, and Institute of Marine Engineers, INSA, and Fuel Spec for supporting this initiative. Thank you very much, one and all. With this, I end this session.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.